Hello, I'm MC Toon, and it's Tuesday night, and this is the first time I've been back at home for 2 weeks. So if you joined me 2 weeks ago, I was on the road, and last week I just had a premiere. So this is the first in 3 weeks, actually live streaming here. So welcome. This is your first time. Be sure to do the stuff that you should do. Tonight I will be debating the Cosmology Tartaria server. If you are familiar with Fight the Flat Earth FTFE, he has also been enjoying debating them. Shane St. Pierre, a good guy, a flat earther, but he has invited me to come a while ago. He's like, "Hey, won't you come back?" I said, "Okay, I will." So I will be joining in there momentarily. Let me make sure I have, I got all the stuff here. So I will, I'll try it. If there's some super chats that come in, I will try to incorporate them. But I will most definitely get to them after I wrap up on the server there. So anyway, all right, I'm going to pop in now and make sure that, let's see, you should be able to hear it. Oh, there's a lot of them here. Let's hear. Look at this. There's a bunch. So, oh, and I didn't mention, there's a lot of new members. So thank you very much to Siggy Sigwald for that. And so welcome. I have them in the scroll. Oh, hold on. The scroll right here, right down here. All the new members should be in there, as well as the outro scroll. So there it is. All right, here we go. Into the server I descend. And so you know, they've got an ambush for me, but I know it.
Swine flu, which was just a flu, and bird flu, and we spend a lot of money. We spend a lot of money on bird flu research, bird flu vaccine. Yes, humanity, collectively humanity.
No.
Yes, world governments, humanity, the taxes that get given that are gotten from people like you, Michael. So a lot of money is spent on research for things like bird flu and swine flu as well. And the coronaviruses were the last two major threats that we had in SARS and MERS. And SARS actually had an mRNA vaccine developed for it that never got fully out because SARS was controlled because it was less infectious. So all of this makes perfect sense why Bill Gates would go, okay, what's the next?
So for you wondering, I'm muted on their server, so they can't hear me. They're talking and they know I'm coming, but you know, they're going to have to wrap up what they're talking about here.
No, I honestly think that you should go to Destiny server and talk about how awesome you are.
Hey, Dodge, does the mainstream narrative's dick have a taste? If so, can you tell us what the dick tastes like?
I just want to read this off real fast. This is what it says, right? It says that the vaccine has not been...
Ooh. So I'm not, it's Witsit. He's talking trash about things that YouTube doesn't like. So I'm not going to, we're not here to talk about that. So anyway, come on, Witsit, wrap it up. Yes, Witsit. Witsit is doing what Witsit does. Searching for things that support his pre-selected conclusion and ignoring everything else. Yeah. All right. Oh my gosh. He won't stop. He won't stop. That's just objective. He always says. Oh my gosh. All right. Come on. Witsit, wrap it up. So, all right, come on.
No, I've known for a long time they didn't test for all potential negative outcomes of the vaccine.
But
and that makes perfect sense because people were dying of COVID and they needed a vaccine. So they tested for the ones that would cause immediate or severe problems. And when they found that there weren't any immediate severe problems.
All right. Jeez. Yeah, Witsit. Extra J says, except for refraction, he says you can't ignore that. Exactly. Ooh, hold on. All right. I played his thing, but it's muted right now. I'm not. All right. Oh my gosh. I would thank Titicaca it's Tuesday, but I can't support Tartaria Tuesdays. I get it, Dave. I get it. They are a tough group to have there. So anyway, Stringfellow Hawk says Whitsitt could be dead for 5 years and he'd still be talking. That's funny. Shane sent me a message here. All right. So I think they're in my head. I think that Shane will probably jump in here and introduce the thing. So they'll wrap it up here. Hopefully in a second. All right. Pay necessary. There's this, sorry, I forgot everything Whitsitt says comes from the burning bush. So Whitsitt never supports his citations. Never. He never does. He just, sometimes I'm going to take that back. Sometimes he does, but they never support his position, which is the first law of flerf. And it's Whitsitt that primarily, drove that particular observation. So, okay. Oh, Shane's in there.
Yes, you all wear very much when I pop in and talk.
I like you, dogs. You know, I get sick of you sometimes.
Oh yeah, you just.
That's why I'm respectful to you, Shane, most of the time. It's Michael and Wix that I'm not respectful to.
Oh, shut up, dog.
Hey, how you doing, Shane?
Hey, man.
Prepare that message to David, dog.
We are super trolly active today, I guess.
He's my daddy. Michael Toon. Daddy, I've got the evidence. Can I present the evidence?
Who the hell is Frank Burns?
It's Frank Burns. Frank Burns lives in Australia.
Let me produce the evidence. I can prove that Michael's my father right now.
Who?
Frank Burns has evidence that I'm his father, apparently.
Oh, I thought he was talking about Battle Mod.
Oh, okay. Nice to meet you, Michael.
I'm confused.
We've met before.
Yeah. Well, I just thought he was referencing me. We're both Michael. Now you're not confused. Okay,
have you guys met before?
Got it. We've met.
Yes.
Oh.
He said Michael was his daddy, and I said, "Oh shit! What? I don't remember that time in Australia. I drank too much."
When you were in Australia, all right.
Hey, Vegemite and liquor,
Nope, I don't. I'll have to take your word for it.
I'll tell you that, yeah.
A little pub crawl,
Who is this
Vegemite.
Earth that constantly posts open 24 hours? We can do this all night with the, I don't know, is it coffee?
Oh, it's a bot.
Oh.
No.
I got it.
It says bot. Right.
Oh, it does. It does.
You can read next to it.
It makes us tell you that it's a bot, so we can't actually trick you with stuff like that.
All right,
it does that in the live stream channel whenever somebody joins the server.
Yeah.
So
wait a minute. The new
tunes that are problem with the bot.
You guys got coffee in Australia, don't you?
Were you trying to say something, MC2?
No, I apparently where the topic is coffee in Australia.
Well, we do a wide variety of topics here.
Well, if you're wondering, I am currently live streaming on my YouTube channel, so anybody just be aware. Yeah, what you say goes out there.
Thank you.
Say whatever you can to get that channel banned.
Let's talk about how safe and effective things are. Can we do that?
Do y'all need some help? Somebody call
I
me.
think that's the topic.
Well, I mean, it would be kind of like a bitch move to vindictively get MC Tune shut down that way, I think.
I agree.
I wouldn't care.
Touche.
Wow, Frank Burns posted some evidence that is difficult to refute.
I didn't know you had as many haters as Witsit. Oh, this is cool.
This is fucking funny.
This is fucking
That's
ridiculous.
awesome.
He's like,
Happy
look,
birthday,
there's him.
Frank.
Does
You
this guy
taught him
just
how
like
to ride
follow
a
you
bike.
around and tell everyone that
No,
you're his daddy?
Frank,
Oh.
Frank, he's just funny. Frank
Frank's a
sent me.
Glober.
He sent me the photograph of Gemini taking off, the rocket taking off. That's on my wall behind me. So apparently, because I taught him how to ride a bike. So look at how fit my legs are. Oh yeah.
That's been photoshopped.
How do you know?
I can tell.
$20 says you have cankles.
Cankles? Hold on, let me check.
You could tell it's real because it looks so fake.
I'm missing the cankles.
Bat, you mean bat?
I'm going to download them and run them through my CG on Detector Tron 2000. That'll fork it out.
My images come out awfully big lately. What the hell is up with that?
I think it's an update Discord did.
Yeah.
I want to see McToon do some squats.
Well, I guess you'll have to come here in the morning when I do a workout, I suppose.
Chicka chicka wow wow.
Yeah.
Hey, is it cool if I don't see McToon do squats? Is that fine?
Yeah. Please,
I'd be in that boat.
Feel free. So, all right. So just for reference, in the last stream I was in, FDFE had a poll on who, if they could choose just one OnlyFans account, if it was FDFE or me. So go watch that stream to see who won.
Which other server were you at?
It was on FTFE's live stream on YouTube. So, yeah. All right. Well, I'm
Did you
here.
say
I'm here for
OnlyFans?
a yes, I did. Neither of us have one that I know of, but
I hope not.
Yeah.
Please stay as far away from that as possible. I don't think anybody wants to see that.
I only know of it because of people talking about it. So yeah, I there you go. Yeah, there was no vote for neither, unfortunately. So all right, Frank Burns demands to be acknowledged. Frank Burns, I think that's Photoshop. I'm going for Photoshop there. So
You can
all right.
you can keep posting memes, Frank, if you want. That's
In case you don't know, Frank Burns is a character from the TV show MASH, which was during the Korean War.
Yeah.
I didn't know that. That's
there you go.
4077.
That's way before my time. You guys are old.
Fuck you.
Yeah, I'm only 13, so I wouldn't know.
You said boomer improperly, bro. Can you
Didn't
get
know
that
you
boomer
self-identified that way now, Michael. I'm glad you've come around.
Fuck it, it makes it easier. They say boomer just means old, so whatever.
All right. Well, I'm here for a specific purpose.
Okay, boomer.
Let's rock. So it's my understanding that there are some people that think the Earth is flat, and that's a strange one. So does anybody have like evidence for this?
Badamad, you hot micing as usual. Thanks.
I mean, I kind of do. You know, I've been out with the guys doing lasers and mirrors, and we've changed the variable quite a bit and shown that we've got same-day extremes that would have affected the light's calculation, yet the light tends to sort of parallel the surface over land, water, and ice repeatedly. So I would say that the predictions of the bending of light don't match what we can see.
Well, did you
experiment
to be complete? Did you measure the lapse rate?
I'm not sure what even lapse rate is.
Oh well, it's if you're going to be taking into account the effects of refraction, measuring the lapse rate is a good way to do it because it removes a lot of the guesswork. So the lapse rate would be the vertical temperature change.
Okay, it's what they're calling a temperature gradient.
Yes. Yep.
Yeah, that's sort of a last minute thing that's been thrown in my way. So also I've been told to do different altitudes and different distances. But, you know, I've done all that pretty much. And I just want to ask you what you think about Nat Geo's observations that they made and put out into the mainstream, which is, you know, where you and your audience are. So I understand globe culture. You know, it is a culture that you're brought up in. But when you look at blatant lies being presented that you can see and can't explain, like most things are explainable, I just wonder what you think about the repeated work at the Salton Sea and the ability for both Discovery, PBS, Nat Geo, and the IIG group to put out videos all claiming to show a globe there.
Yeah,
Are you familiar with any of that?
I'm familiar with some of them. Of course, none of them are things that I have ever cited, as far as I know. So
I can just tell you honestly that whether we use lasers, different color lasers, which should travel, you know, at a different wavelength, mirrors, infrared, we kind of parallel the surface wherever we go at different distances. And it was just brought to my attention that if there was a curvature to my light beam, it would hit the water. So theoretically, I would have to be pointed upward. I'd have to be out of level. At which point now the new argument is, am I capable of achieving level? Which is sort of silly as well.
Well, you know, over the kind of distances that people tend to do, aiming a laser and having it be truly perpendicular to vertical at a high margin of precision is actually pretty difficult. The FE core people at Lake Balaton created something. I don't know how precise it really was. I think they focused more on the name than on precision. They called it salad. They
trust me. Yeah, trust me. There's so much bullshit in that I can't even go there. Please don't mention them. And they're bullshit.
So yeah, I other than just to say that I appreciate the difficulty in getting a laser truly perpendicular to vertical, but the other problem with lasers is, of course, that they do expand. They're not just pencil thin. They expand into a cone. And even when you have a good collimator on it, it still happens. Just
sure,
it reduces
the beam diverges. I don't think that disproves that we're seeing a target, though. It just means that the target got wide.
The target's big. So you move the camera in a broad vertical range, and you see it in a big range. So like I've seen where if you know Mikey Smith from poor Mikey Smith. I mentioned Mikey Smith because I know Frank Burns likes him. But Mikey did a laser thing where his entire car was illuminated by the laser. The whole car. So, I mean, it really expands out to a pretty large area. So if you see, one of the ways to test for that over water, if it's kind of smooth enough, is if you see like a long reflection over the surface of the water, that's a hint that it's actually bouncing off the water, that the cone is large enough to get that far down, and however high you're seeing it still.
So have you seen the Nat Geo stuff?
Let's see. Is that the one that you just posted there?
Those are some stills from it.
Yeah.
Were you there, Dan?
Not that day. Everyone was at my house the night before that on that one.
Yeah. I haven't done an analysis of this. I'm not too impressed with it. The stuff I've seen. So that's the one where Mark Sargent was standing there, right?
At that particular one, on that particular time, I just to run it down, you know, with you, PBS Discovery did something that was debunked by flat earthers because the foreground was reused as they pretended that a helicopter was able to dip beyond this horizon. This horizon area is 9.6 miles away in everything I'm about to discuss, because that was the first time. The beginning before this flag experiment that you see was a balloon experiment that was completely pulled by Nat Geo because we saw the balloons on the ground and they couldn't start because they couldn't find the starting point. We had to do that for them, therefore debunking it, but I could show it to you. And in fact, we can see across this span quite easily with the bare eyes, with infrared, which I can bring up as well. The point is that this span is not dramatic. It's been reused and reworked. Mainstream has used this opportunity in this case to say that they saw some things that they clearly didn't. You can see it in the camera, including the horizon, or what we're going to call the coastline, well beyond the target, some 6 miles beyond it. So I was there many times subsequently shooting mirrors and lasers, and I'm going to suggest that the burden of proof that light bends mathematically be demonstrated, because we have demonstrated it not to happen under temperature extremes and different conditions, like light, with daylight, nighttime, infrared, over ice, over water, over land. We kind of covered some of the bases enough to say, hey, show me your prediction of light bending and let's see it happen. And
all right.
I'm just standing on that for a bit.
All right. Well, I will. I'll start with this. Let me get the title of it here. From NOAA. Results of leveling refraction tests by the National Geodetic Survey. So there is. I'll put the link to that there, and I'm going to put it up on the screen here so that people can see it on my side here. So I gave you the link there if you want to look at that. But this is it's 28 pages, so it's not too long. But what they did is they have several rods where they with thermometers on them. And on page 4 of the document, which is page 10 of the PDF, it has some photographs of their setup there with the different thermometers on it, digital thermometers, and the particular rods that they used to measure the vertical temperature gradient. And they did an entire grid of 9 points. And they measure
vertical. This is all vertical gradient, right?
Yep. Yeah, they're measuring vertical gradient.
So what if I tell you that these tests were done way below that variation? You know, that these were done under 6 feet of height.
Okay. There's still a vertical temperature gradient. That doesn't make it go away just because you're lower. So, in fact, the most of the measurements that I've seen, the closer you are to like the surface of water, the more pronounced the temperature gradient is. So that increases the.
Would you assume that that the standard refraction that they use includes that gradient?
I don't subscribe to any standard refraction. What they use typically for standard refraction is a K is the coefficient of refraction of 0.167. And that was measured by, if I remember correctly, by Gauss, from between two points that were well above the ground, and all of it was over ground, none of it was over water. So
walking that one back, that's cool.
If you don't have specific measurements of the vertical temperature gradient, well then what can you do? You can look at similar measurements of the coefficient of refraction and the effects of refraction in similar conditions. So if you're looking from a high point to another high point, all of it over land, and it was, I think it was like not trees, it was like grassland or something like that, then that would be a place to start, and maybe have that be in one bound of your range of the coefficient of refraction that you use. So anyway, this particular measurement, so this thing I linked is a measurement of the vertical temperature gradient, and they use that to convert to the coefficient of refraction K, and they compared the predicted refraction based on their modeling to the measured refraction based on the measured vertical temperature gradient, and how much the the sighting raised or lowered, and they found that they were in very close agreement. I think if you get to table, if it's been a little while since I've reviewed this. Table 3 balanced site results. There you go. Table 4. This is on page 18 of the PDF. Table 4 balanced sites error estimation. And they did things during the day. They did things during night, and typically that does have an effect, especially shortly after sunset, especially over water. So anyway, there is some pretty good, and that's just kind of a teaser because that's just the beginning of the documentation of the measurements of the effects of refraction in the air. I have quite a few more things that I've reviewed, and some that I haven't yet reviewed in detail on my website under my refraction page, mctoon.net/refraction. I'll put that in.
I hear you, and I agree with you. I just want you to know why we use the Salton Sea, and it's because it's heated geothermally.
Yeah.
And it gets up to 85 and 90 degrees, and a couple of times a day, the air and water will match. And I believe it's one of the lowest possible refraction rates anywhere. I think I have some documentation on that it's in the negative numbers. So there's a reason why you go on a clear day, and there's a reason why you might choose a location that, remember, refraction is really the result of humidity and temperature inversion and other obstructions like smoke or haze, so it's not one thing. And I'm going to really suggest that refraction has not been an issue on a clear day when shooting in the distance. It's just
yeah. Well,
we
so
have line of sight.
I think the Salton Sea sounds like a good place. I would think you'd want to probably do it on an overcast day, because the sun, the sun can heat things inconsistently. So if it's overcast, then it's going to have less of that effect. But definitely measure the vertical temperature gradient. I have you can't see it because you're not looking at my live stream, but I have a NIST traceable thermometer and a hygrometer that industrial nerd sent me. He's a metrologist, so he deals with measuring things and being very precise in these measurements. So he sent me one to use. I have tested it out, but I intend to go to it's winter here in Minnesota, so I intend to go to a lake and measure vertical temperature gradients over the lake, both daytime and nighttime.
All right. Well, I appreciate your time. I just want you to know we took it over to the salt flats, and I can show you lasers in a gradient of distance, 5, 10, 15, 20, 25, 30 miles.
Yeah.
And to me, that's an important gradient when measuring the Earth. If I can just prove to anyone that that's level ground, even though the place is called flat, I seem to have trouble getting anyone really to copping to the term flat or level.
It's called that. That doesn't make it that way. It's just what people call it. And I mean, you just posted a picture there that has the curved. It shows a curve. I don't know why I posted it, from David Cook.
Well, it shows what looks like a curve.
Yeah.
But when you see the elevations, they're all...
Well, it's not opinion that surveying defines level as a curved surface.
Well, then I'm going to ask you again to define your refraction in prediction and show me your light beams refracting in the way that your math requires, because I find it coincidentally matching 8 inches per mile squared. And I think that's
you
a
find
pure
what
coincidence.
Matching 8 inches per mile squared?
Light beams. In other words,
it's
the
rare.
Curvature of the Earth just happens to match your refraction value. And that's
I think that's probably going to be pretty rare conditions.
Well, I can show you over 35 observations with documentation alongside that shows that to be true?
Well, certainly send that to me. I'd love to have a look at it. My email might be the best way for that. mctoon@mctoon.net, unless you have a link to a website or something. You could just DM me in Discord here. So
okay,
I'd love to look, but like I said, the one document that I linked is an empirical measurement of the effects of the vertical temperature gradient, and comparing it to the predictions of how the coefficient of refraction deals with it. So, and I'm
all right. So you have an explanation, and I've got over 35 observations that show otherwise.
Okay.
So when you ask for why I might even dabble in the word proof, it's that I think we've achieved line of sight under too many conditions to attribute it to refraction.
Yeah. Well, definitely let me know after you review the documents I have on
You think I've
refraction.
never heard of refraction or the effects upon it?
I suspect you probably haven't read any of the things that I'm talking about that I have on my page here.
Well, we definitely talk about it a lot. And I also told you that I'm generally working underneath a large enough gradient to make any difference.
I don't know how that there's still a gradient. Unless you measure there to be no gradient in that range that you're working in.
Well, what if I show you a temperature range at the same location?
But you already said you've never measured the lapse rate, so how are you going to do that?
All right, you got me.
All right.
We can move on.
Yeah, anyway, send them to me. I'd love to look at them.
Thanks.
All right, thanks, Dan. Anybody else here? There's a lot of people here today. Well, I'm glad to see you all. Welcome.
Why, hello there.
Whose voice is that?
It's Mick Smurf.
Mick Smurf.
Your worst nightmare.
I like how he self-identifies as Mick Smurf because someone changed his name to that.
Hello, guys. Check this out.
I was molded by Mick.
What? Oh, are you just Smurf here? It looks like.
His name is MC Smurf. Mick Smurf, okay?
MC
Smurf.
Smurf. There he is.
MC Smurf, you?
I mean, he's trying to do y'all. He's trying to do you a solid, but shout out.
Absolutely.
Right.
Bring it on. I love it.
Okay, so Mick, I don't know. I'm asking the panel.
You asked for it.
It sounds to me like McToon. I've never seen you more or heard you more respectful, and kind of just upfront and calm. What are you? I'm not gonna ask if you're feeling okay. I'm just kind of like telling you about it, I guess.
Well, I'm guessing you probably don't regularly watch my channel, so I do prefer to have a nice civil chat.
Oh, okay, all right. No, I don't watch the channel. I do apologize.
About 3 or 4 weeks ago, I went on to Jaren's channel. I popped into his 3 minutes thing, and he kindly gave me a little more than that. We had a nice talk. Some people can clash and some people don't, and Jaren and we did not. So I don't know
all
how
right.
I'm not saying that Jaren is your guy or anything, but
I think it speaks to a broader thing that we can all be humans to each other if we just focus on that too as well. Like, here's the information and here's how nice I can try to be about it. Maybe, I don't know.
I agree.
To see if we all did it, that's ideal, but right.
Well, I mean, hey, let's try to be a little bit less nice to each other. So yesterday we were watching a debate of you and Alex Stein, and I don't know what happened there. Is that the only time you were on Modern Day Debate?
Oh no, I've been on there quite a few times.
Oh, yeah. Did you go back after that experience?
No, I did not. And so
that was the last one.
That was the last one, and there had been a few other things that were part of my saying, I won't. What I did say is I said I won't go back on except if Eric Dubay. And I told James that. I've spoken to James since then. I'm like, well, I mean, I don't have to be super strict on that. I don't. But I did say I won't go on unless it's Eric Dubay. So I'm like, I don't want to shut the door to Modern Day Debate, but I do appreciate, and Shane, to you, I do appreciate that that you're here and that you do run a nice pretty, you know, you let us everybody kind of talk and not steamroll any one particular side. So I like that.
Nice. But like, so I'm trying to figure out, you rage quit that one and then never went back. But
well, no. So if you watch the whole thing, I told Amy was the moderator and sort of moderator. I mean, it's generous calling her moderator.
She didn't do anything. But
I said, Amy, I can't talk. I keep getting interrupted. If you're going to do that, I can't be here. There's no point. So call it a rage quit or call it just there was nothing. But she did come on my show then and spend, I don't know how long, half an hour, an hour. And she apologized for it.
Oh, so I mean, she did say she sent you hearts. Does that count for nothing?
Sending hearts counts for nothing. It does not count.
So did you not know? All right. So my only question with that, did you not know who Alex Stein was before that?
I did. I did not know when I accepted it that it was going to be Amy moderating. I thought it was going to be James.
So you were prepared for Alex Stein, but with James, is what you're saying?
Well, because James would do a little more, I think. And people might disagree with me, but I think James is a better moderator than Amy, and I think he would have stepped in, and he's done this before, where he'll give alternating times to talk.
Right.
And that's obviously what needed to happen there, because there were, you know, he was just throwing out claims, and I start to examine a claim, and then he won't even let me finish a sentence. You know?
Yeah, I mean, well, that's Alex Stein. He also got up halfway through to show that he wasn't wearing pants and in his half suit. Also Alex Stein. So
yep. Yeah, and I love his green screen where he's got like the big grand piano in the background, and I mean, I don't know what it is without the green screen, but certainly not that. So
it's a sadomasochistic dungeon. That's what it is.
We did find some flat Earth evidence today. If you're interested.
Oh, that would be a first. I'd love it.
I can show you where it is. Ready? It's at mctune.net.
Yeah.
-se.
Yes.
Right. And it's from the Transcontinental Triangulation on the American Arc of the Parallel.
Yeah.
And I think it's page like 72. I think we made it a nice meme, so I'll just throw that in chat. And there's some measurements that add up to less than 180 degrees, and a couple that add up to directly 180 degrees.
So, I am aware. Do you think when I typed all of those numbers into my my spreadsheet that I made that I didn't see them?
Well, there's like video clips of you saying that there are none in there, not one.
And there are not any that sum to less than 180 degrees. So what you're looking at there is the incomplete measurement.
So I see. So the actual measurement before you apply the correction math to make it spherical is what you're saying is never less than 180 degrees.
No, it is not to make it spherical. So let me show. Let me see here. I have them. I have a few things I can send into the chat here.
You're saying none totaled less than 180?
Yeah, the final numbers, none of them total less than 180. So what you're looking at, so let me I'm gonna switch it so people on my mine can see that. And so this is the one you're talking about is the first observation on page 62, the first four, I think. 1, 2, 3, 4, 5. All right, so it's actually measurements 2, 3, and 5 that sum in the intermediate value to less than 180. But in the final value, when it's the completed value, they all sum to more than 180 degrees. So let's see here.
But the completed value.
You understand how that seems weird, right?
So what are you doing in the actual correction calculation besides adding the needed amount to make it over 180?
Oh, yeah. I'll show you. So they don't actually add the correct amount to make it any particular number. I want to make sure I get the right page here. So I sent a PDF there, right? It's a part of the full thing, page 58 to 63 of the actual PDF, but it's actually page 58 or page 57 of the actual document. You know, the PDF and the document, the printed document, don't match the page numbers. So if everybody wants to look, I don't know, Shane, maybe you pull it up. It is page 61. No, hold on. 62. And like I said, it's the measurements 2, 4, and 5. And they sum in the observed angles, they sum to less than 180, but the adjusted ones, the corrections. Now, what they do in the corrections is important. And I'll show you this. Now, if there it is. This one here. So when you do a measurement, all measurements have a margin of error. Every one of them. So when you are having things that converge, when you're measuring things that converge, they're not going to converge when your precision is close enough. You can zoom into your precision, and you'll see that they don't converge to an exact point. So this particular graphic is thanks to Andrew Johnston, who was on with Flatzoid, and he had a great diagram here. So I just used it. So what do you do when you see those 1, 2, 3, 4, 5, 6 different red dots? Those are where the lines cross. But those four lines, A, B, C, D, they don't actually cross in one exact spot. And that's because it's a measurement. All measurements in reality are imperfect. So what do? You have to average them. And we do that in celestial navigation. We do that in everything. So there's the diagram there, you can see. And then you pick a point. Typically you average it right in there. So they actually did that. And that's what they're doing. And I'll go to, so you look, let's look here at, it's triangle number 2. You got Marriott, Taylor, and Kent North Base, Kent Island North Base. You see that? Now if we go back to the PDF, page 58. So if you look at page 58 of the PDF, you'll see that they have these corrections from the base net adjustment. So when they do this base net, it's a whole series of triangles. And so they're using all of the triangles in the net to get the precise point that they're gonna, that's the average of the intersections. So that's what they're doing there. Now you'll see, for example, if you look at Kent Island North Base, it's the second one there on that page, and it's listed. So if you're looking at page 58, listed as 4, 5, 6, 7, 8, and it's Kent Island South Base, Marriott, Taylor, Linstead, and Swan Point. You see those? And then that column there that's corrections from base net adjustment says plus 0.19, minus 0.47, minus 0.12, plus 0.16, plus 0.24. Now those are the adjustments that they made to the specific angles between Kent Island North Base and these different ones here, these relationships. If you sum all of those numbers there, you will find that they sum to 0. Except on farther down there, they had a 0.01 positive and negative, and that's because on page, let's see, just for note, page 59, it says they've identified some errors in some measurements that they included. But anyway, I'm scrolling on my live stream here. So you go to those there, and they sum up. Now, if you go to my webpage, this /SE that you mentioned,
yeah,
I added this today actually.
Look at that.
What are the adjustments?
Did you talk to Brenda?
Sheet 4. No, Brenda didn't. I mean, I talked to Brenda in the live stream with FTFE. All right, so here we have sheet 4. Shane, if you look at the spreadsheet that I put up on the page, all right, mc2.net/se. And then sheet 4. Are you there? Tell me when you're there.
On your survey area, sheet 4.
Survey.
Yeah.
What survey?
Starting on page 42, starting on page 53, starting on page.
No.
Links, right?
Oh, so on
the website.
on my website, there's a thing that says link to spreadsheet. Do you see that? Oh, I can put it in the live chat.
Nope.
What was I thinking? I can just
Dude,
put it
there
right
it is. All right, I got it.
There you go. All right. So.
Oh yeah, this thing.
There's the link to spreadsheet. So you go there, go to page 4. Now I added this today. Brian Leak posted his video in my Discord server early today, so I saw it from Brian. So thanks, Brian. Anyway, so if you look at these, and what I did is I just typed in the numbers for that one particular adjustment there from the base net. And you see that they all sum to 0, and you can go change some of them and see if you change them. Well, you can't. You'd have to duplicate it. I'll do it. I can't. I'm viewing this in an edited a private version as well. Anyway, that sum column actually sums up the values there of the previous ones. But you can do it yourself. That Kent Island South Base 0.03. 0.06 and negative 0.09. Obviously, you put them together and they're going to give you a 0. All the others are the same except for Marriott, Linstead, and Finlay. They had, and there's a note. You see the note on page 59 and page 60 where they identified some previous errors. Those particular ones, I don't know if they even were included in the less than 180. What's that?
What are the corrections?
What the corrections are? The actual intersection points that they're dealing with here. So back to what
do you mean?
I'll put it in here in the. So this is just graphically what you're looking at here. So remember, there's this grid of triangles that they do. There's hundreds and hundreds of triangles that they did across the United States, and so all of these triangles have vertices. They intersect at a point, and they don't. When you do the measurements, there's a margin of error. And since there's a margin of error, they don't meet exactly at any one particular point. And so they take those and then they average them to get it into one particular point. But because these are horizontal measurements, they're all azimuthal measurements, there's 360 degrees in a circle going around. If they change one of them somewhere, they can't keep the numbers correct without changing it somewhere else. So they took these averages of these points and it wound up. It didn't wind up. They don't actually change 360 degrees in a circle to be less or more than 360 degrees. So there's the checksumming there. They can't change it just arbitrarily and say, oh, we don't have enough, we're going to add some to force it to work. Because there's only a 360 degrees in a circle. The checksum would fail if they added more than existed. Does that make sense?
Hey, Michael?
Yeah.
Hi, how's it going? I want to ask you a quick question. Why do you give any of this credence? Why does this, I don't want to say convince, but why do you accept any of this as potentially being correct?
Why? Well, it is a high quality survey done by people that really know what they were doing. It was, I choose this partly because it's pre-NASA, and how many flat earthers can't stop talking about NASA? It's almost like they love it, right? So I said, well, this was completed published in 1901. NASA wasn't founded until
Brother, I love
50s.
NASA. They're the #1 globe debunker in history.
Right,
love NASA.
Let's stay on topic here. Anyway, so I choose it because it's a survey done before satellites, a survey done before NASA, a survey done before electronics.
Yes, but that wasn't my question. I'm sorry. Yeah. I'm saying you say that these are correct in some way, or that maybe they're correct. And why do you say that? Why would you say that these are correct when something else isn't?
Well,
Hunter is a big talker and likes to waste a lot of time with a lot of preamble and nothing like questions. But it's your choice whether you want to engage with him.
It's a reasonable question, isn't it, Mike?
Yeah. So what other things are you suggesting that are similar in quality that I'm rejecting?
Oh, I'm not. I'm not.
So things.
It's a positive question.
Things that are similar in quality, I will definitely give a lot of credence to, and of course, I'm not going to just blindly accept it because it matches, or just because it looks like it was quality. I will definitely review things. And so, like I said, when I was talking with Dan, I noted, and my website notes this, that I have a list of refraction measurements that I've reviewed, and I have a list that I note on my website that I have not reviewed.
But okay, let me ask. I'm sorry. My question, though, really is it true? Is this true that you accept it because the people who provided this ultimately provided hard data? Yeah. They provided an analysis of exactly how much error there was involved, and they provided a full set of analytical mathematics that showed their work. They showed their work. Is that not correct, or no?
Yeah, that's all good points. Yes. And further, I think it's important. When analyzed, they don't have errors in their application. That, at least not that I've seen, and not that anybody has pointed out to me. So that's another part of it. There's certainly things that I've seen where there have been errors, and so then does that error, it doesn't absolutely reject everything just because there's an error, right? You can reanalyze things yourself to fix the errors. That certainly happens plenty in peer review documents. So,
and that's kind of one word right there, two words right there is kind of what I'm getting to. Peer review. Else? People looked at it. And they either accepted or rejected it. They didn't just put it out there and say, this is right.
Terrific. The profundity is shocking. Does anybody else have any questions?
Shane does not like Sky Hunter.
How big are these triangles?
That's what I was going to say. The triangles are particularly small in that condition, in that particular example. They're only like 11, 12, 15 kilometers long.
Who let all the Globers in here? What happened today? The hell
well, all right. Well,
and you look at the corrections. You look at the corrections there. You're dealing with fractions of a second. Fractions of a second.
Yes,
really tiny.
I understand. But when you make broad sweeping statements that there is no measurement less than 180, or one of 180 would be flat Earth proof, and then say, well, it doesn't really matter, it's kind of goofy. Anyway.
Well, Shane, like I said, there are no completed measurements that are less than 180. What you're looking at is a partial measurement that's not complete, and saying, oh, the partial measurement is the one that matches my pre-selected conclusion, therefore it's the cherry that I'm going to pick. No, you need to look at the full work and the full analysis. And if you look at the reasons why they did, and the specific analysis that they did to apply it, if you think it's wrong, if you think that they did it just to force it to look a certain way, then that would be something that you could show mathematically, numerically, or through some analysis. To just say, oh, it doesn't match, therefore they must be fudging it. Well, no, show the fudge. It's all there.
Well, why would we think that? They're all 180, give or take a tiny, tiny little bit.
They're not all give or take. They're all more than 180.
You're like right at 180.
Well, yeah. So the margin of error, reportedly based on that the top of the formula there, is like about a second. So like even if you measure over a second, it's still within the margin of error for perfectly flat at 180 degrees.
So all right, and I'll that's a good point. So I will bring it up here. I have it. It's on page. I think you're talking about page 50. Page 60 maybe. Hold on.
I think it was right on the page we were looking at.
It's on 62. All right, yeah, it's on page 62. So just immediately above the triangles of the Kent Island basenet, right? The number 1 through 5, where a 2, 4, and 5 are the ones that you're looking at in particular. So the mean error of angle is plus or minus 0.87 arc seconds. And the probable error of the same plus or minus 0.59. So that's a good point. So if that type of precision is not to your liking, I understand that. And
no,
so
it's very much to my liking.
Yeah, it's very much to my liking too.
Well, then you can say, well, we could throw it out and not look at that one because the measurements are within the margin of error. And that's for this particular thing, that's a perfectly relevant thing to do. Or you can say, well,
take it down off your website then as being glow proof, right?
No, not at all. Because, and I'll show you.
Oh, okay.
On page, here we go. Now I'll start with this one here. This next one is, I'll begin with the margin of error, the similar one. This is on page 218, where it's a little bit above page 218 is where that margin of error is. So if you look at that, the mean error is 0.473. You can see there's an extra digit there. So they've done more work to get an additional digit of precision. You don't just get an additional digit just because you choose to. You actually have to have some reason to have an additional digit. And there's reasons in there. And we can get into that if you want. But anyway, and the mean error of angle is 0.668 arc seconds, and the probable error of the same is 0.45 arc seconds.
Yeah, we want to get into why.
All right. So yeah, you're a little late witted, but anyway. So
I know,
here is the page 218. Ooh, I got to jump down here so I can see it. So I dropped in page 218 of that survey, and you can see there the triangle number 28, Ibapaw, Pilot Peak, and Ogden Peak. Now the sum of the observed angles is 180 degrees plus 62.16 arc seconds. And after the corrections, it was 62.660 arc seconds. These are significantly larger triangles.
Why does it say 62 arc seconds? Shouldn't it say like 1 arc minute and 2 arc seconds?
I mean, if you wanted to have your notation be that way, then you could. But they chose not to do the notation that way, probably because...
It just seems like an error to me, like a typo maybe.
No, it's not a typo at all. It's probably very intentional. It's probably very intentional that they left it as arc seconds instead of rolling up to arc minutes.
Because, that's the only one that's like that, right?
No. There's number 28 has that, more than 60 arc seconds. Number 30, hold on, I'm not done. Number 32. I only have this one page up at the moment. So why would they do that? Because they're going to be doing math in the arc second range on them. So that would be one reason to do it. And then another thing, if you look at this column, this is log S. Do you know what that log S is?
Dude, what?
Log S, yeah. So page 218, I just dropped it into the chat there. So log S, that's the log base 10 of S. S would be the distance in meters. So if you take that 185,460.68 meters, which is the very far right column there for the first measurement on page 218, and then you do a log base 10 of that, you get 5.268.251.84. That's the log base 10 of that particular number there. And they do that because they didn't have computers. And so they do things in log form because there's particular things that they can do that's easier and requires less math. So they actually use lookup tables and slide rules to do logarithms. And then they do math in that in the log, and then they'll come back out of that because there's a shorter process to do math. It's not relevant to the spherical axis that we're looking at here. They use it for, they're measuring the length across the United States. So it's not just the spherical axis that they're looking at, but we're interested in the spherical axis. So anyway, that's beside the point. So you see these are 62 arc seconds, 39 arc seconds, 62 arc seconds, 12 arc seconds, 72 arc seconds, 33 arc seconds. So when you're talking about the margin of error, and this one, the margin of error is 0.473, 0.668, right? So you can sum up those margins of error, and they're significantly less, an order of magnitude less than the actual measured spherical excess. So the margin of error in these is definitely not a problem. We're definitely well outside of the margin of error for these particular ones.
But not the ones that we started talking about.
Yeah, the ones at the beginning. If you don't like the margin of error being that close to the measurement for the spherical excess, I get that. And so the appropriate thing to do would be to not consider that and instead look for something where the margin of error is an order of magnitude less than the measurement.
Right, but you don't think that it's kind of weird to present evidence that it's so greatly over 180 degrees that it proves spherical Earth, and then say, well, actually, we can't measure within degree of accuracy of a second, and actually say it's only 1 second more than 180 degrees, therefore Earth is spherical. You don't see like issues with that.
Yeah, I would certainly say that those smaller triangles are not nearly as interesting. So I agree. I would say don't consider them as part of the evidence for or against, because both flat and globe fall within the margin of error. So it's for this particular type of observation not all that compelling. That's why I say, well, this page 218 is definitely a more interesting one.
Wait, not that interesting and not that compelling. I thought you were supposed to be objective.
Yeah.
That's not objective.
What do you mean?
It's not that interesting and it's not that compelling. These are autobiographical descriptions of your subjective state.
Okay, well, we're speaking in English here, and I'm not writing a semantic paper, so I apologize for not using precise enough language for you.
But you're supposed to be making an argument about the objective empirical state of the Earth.
Sure. All right. I will gladly amend my statement then. Then I will say that the measured triangles and the spherical excess on page 218 are strong confirmation that the Earth is a globe and an absolute falsification that the Earth is flat. How about that?
Okay.
Somebody asked, were you going to remove some data? And do I not have a right to speak?
No, sorry, I had a phone call. What did I miss? What was this amazing? What did I miss?
Somebody suggested that you remove some of this data, right? Why won't you do that?
Why won't I? Because it doesn't that contradict the globe, and I wouldn't remove.
What if it did?
I wouldn't remove data that didn't agree with me, because that would be subjective. That would be using the anti-scientific method. You know.
That it would be a lie.
I don't buy
it would be lying. No, it would be lying. No, it would be lying for him to remove the data.
You guys selectively ignore data all the time.
All right. Well, so you say, Austin.
Yeah,
what do you think about this, Austin?
Like how your galaxy cluster mass prediction was off by 99%. We'll just ignore that part. We'll just ignore that the geodynamo model is completely wrong. We'll ignore that the magnetic field of the globe doesn't have any symmetry and it's 35% weaker in the south.
Wow. Amazing stuff. But none of this contradicts the globe. All of them, Austin, all of them agree with the globe and do not work for flat Earth. So thank you for that.
All of them
I
agree
do
with
appreciate
the lack of symmetry of the magnetic field agrees with the globe.
Yes. Yes.
I thought we were talking about spherical excess.
He had to derail.
Yeah, all right. This is what's so funny though. Like, why are the ballers here? What do you want? Well, can't you guys go talk to MC Toon other places?
Is this?
So this is what I want to know. MC Toon. I'm reading through this paper.
Shane, was that the rule?
Just
Just a second, Austin. Was that the rule? He asked a question. Let's answer the question. Shane, is that the rule that only flat earthers and me are allowed here? Is that the rule?
Well, no, but the ballers just want to like circle jerk and not let the flat earthers.
Austin, I'm asking Shane a question.
Listen,
God damn.
The advertisement was you against a flat earth server.
Let's hear Shane. I'd love to hear Shane's answer to this.
The typical format for FTFE is no globers allowed to speak, just flat earthers, we never actually clarified for that. So it's kind of up to you, man.
Yeah.
If you want all the Globers to be able to chime in whenever you want, whatever they want, I guess we could allow it, but it'll get pretty chaotic.
I agree. I will, but I don't want to, because we didn't agree to that ahead of time. So I don't feel like I could come in here and say nobody can talk but me if you think the Earth is a globe.
I can.
All right, anyway, did you get into the specifics of exactly when you said, because I got a phone call right when I got back over here, you said something about, like, we can get into the specifics of that if you want, regarding like exactly the decisions that they make, because you said, and I quote, they can't just make it up. They're very specific things.
Yeah.
I would bet money you don't know what those things are.
Oh, well, go right ahead.
Let's go. Don't let me know. You're the one that knows. So what is it? Because I've been reading through this a little bit. I've never really looked into all this, and you seem to, obviously you've definitely read it front to back, right? I mean, you know all about it, you say. So what is the assumptions they have to make? How is it that they understand how to correct for the error? What specific variables?
I went over all this.
You
I already
just went over all of
this.
the variables?
Yeah.
Go watch the
Really?
video. Go watch the video.
Yeah.
Pull it back. It's on my channel.
Okay, then what are they?
So the first statement he made, right, kind of made me disinterested with the answer. He said that there are no measurements less than 180 because he was counting the corrected portion of it where they all equal exactly 180. So as soon as I heard that, I went, ugh.
Okay, but yeah, that's right. That's not the question. So the question, yeah, I get that what you guys are wanting to say is, oh, well, you're gonna say that they average them, but they don't until you can point out in the actual paper they say that.
Oh, I did.
Where do
You
they say
missed
they
it.
average them?
Page 58.
Okay, now here's what I'm reading right here. So to derive the probable error of an adjusted angle by the rigorous method involves so much heavy computation in solving the various weight equations that one is forced to use some approximate formula for computing it. Although observations upon different signals in different directions have been given equal weight in the adjustment, it is nevertheless recognized that a difference of accuracy exists and that it is desirable that it should be taken into account by computing the probable errors. This may be accomplished to a certain extent by making the computed probable error for each direction depend upon the residuals from that direction only, instead of basing it upon the whole group of residuals. And this is only one of the many of baked-in assumptions that it blatantly says exists in the methodology.
So what assumption is this related to the shape of the Earth?
See, I'm asking you because you said you already covered all this, and I know you didn't because you would have never read that paragraph. Just one. Don't worry, I got a bunch of screenshots. So let's cover this one. Let's cover this one. So since you say you know all the answers, so the one is forced to use approximate formula for computing it. What's the approximate formula? What is it that we have to guess and it requires such heavy computation that we just have to use approximate formulas?
So approximate formulas are not guesses. Do you not know that?
Hey, what is the approximate formula?
I don't know what page you're looking at, but I did cover
40.
Okay, 40. Well, I'm looking at page for reference, page 58. So on page 58, I'll go over it again. Look at the
we assume.
Okay, I was talking, Austin.
Well, you're just
talking.
You're just ignoring it.
I was talking. If you're gonna interrupt me, Austin, this will end.
All right, man. I guess you're scared to answer. Okay.
No, I'm specifically answering the question, and then you interrupt me. I guess you're scared to hear the answer, Austin. Is that why you interrupted me, Austin?
No, I'm not scared.
Okay, so why are you interrupting me then when I'm answering you? Austin.
Okay, can we get back to the
Got
point?
it, Austin? Don't interrupt me when I'm answering you and then say, I guess you're scared to answer me.
Listen, dude, I don't want to moderate you, but can we just get back to the point and not make it a shit?
Remember what I said earlier about being respectful? Have some manners, would you please? Thanks.
No, come on, let them two go at it.
All right. Page 58. Specifically look at lines 4, 5, 6, 7, 8. On those, you have this is the corrections for Kent Island North Base. And you see Kent Island South Base. So this is looking at the angles between them. And you can see that their adjustment is 0.19. The one to Marriott is negative 0.47. The one to Taylor is negative 0.12. The one to Linstead is 0.16. And the Swan Point is 0.24. Now, if you sum all of those, you get exactly 0. So what they did is they used these are putting the points of intersection, because when you have multiple angles to the same point, you never get perfect intersections. So they're using these to adjust these to get to an average point for that intersection. And you'll notice that since they sum to 0, they're not actually adding or subtracting any angles to the measurements. So if they were forcing globe, they would have to add more than 360 degrees to the angle. So when I say 360 degrees, that's because from one observation point, they measure azimuth angles to multiple points, and they sum them together, and they must add to 360 degrees. It's their checksum. It's how they know that they're doing it correct. And they know that it's not possible to have more or less than 360 degrees when you read all the way around at one point of azimuth. So when they're doing these things, they're always making sure that their checksum is 0. So that's what they're doing there. And so if you look at Kent Island north base, Kent Island south base, you got the 0.19. Now you jump down to page 63, is it? 62. 62 of the publication. The 0.19 is in that table there as one of the adjustments. Which one is it? Anyway, all of those numbers on page 658, 59, and 60. It wraps it up on page 60. All of those numbers are reflected in the adjustments, and none of them add to the actual numbers. Now, I had asked Shane to look at the spreadsheet. So if you on page 4 of the spreadsheet, so on my website mctoon.net/se, I have my spreadsheet that has all the spherical excess calculations. I added sheet 4, and on sheet 4 I sum all of those things, those different ones on the different pages 58, 59, 60, to show that they sum to 0, except for there's some notes on page 59 and 3 of them. Go ahead and read those. Anyway, they're not adding any numbers. They can't add any numbers. That's their checksum. If they added numbers, it would show there, because that's how they would have to do it. So that's what they're doing. That's why they're adding these corrections, because the numbers actually need to add up. They need to sum to 0.
Frankly, man, it seems like you're afraid to answer my question, but I will actually address what you just said. So what's the maximum, like, since you say they don't always intersect at the same place, right? So like, what's the maximum difference in the intersections?
I don't know.
Because it has to be less than what, the margin of error? Because if obviously where they intersect, whatever that difference is, that would be a margin of error, right?
Where they intersect is a margin of error?
Yeah, like if I have them intersect here and then over here, like, well, that's whatever that difference is would be a margin of error, right? Like,
you said here and here. I don't see.
It doesn't matter. It's the principle. I'm making
okay.
Sure if
I thought you might have been pointing to something and I missed it. Okay.
No, I'm saying, like, if we're looking at basically what you guys, I guess you're saying is that they average it, and you said you covered that. I haven't seen where they said they averaged it. Surely to God, they're not
58.
just picking a dot out, I would imagine. So let's just say they average it. Okay, my point is, so if you have your depiction where you have all the different intersections, right?
Yeah.
Like, the greatest difference between the intersections, so they intersect at this one point and then they intersect at this other point, right? Like, the greatest difference in the intersections, wouldn't that be like the margin of error? Like, because you already have that much of a difference in two of the potential outcomes of the measurements, right?
Yeah, and if you wanted to, the numbers are there, the math is there. You could do your statistical error analysis on those particular ones if you were curious about that. I haven't.
Right,
so I can't give you that number off the top of my head.
I think 1 arc second isn't about that. So I don't even know. I haven't verified that it's actually 1 arc second, but someone did the math. It might be close to that. I don't really know. But I don't know if you know that. Do you know, like the
What do you
like
mean
at
one
the top of the chart, it says it lays out the margin of error. Is that 1 arc second?
No, there's a couple different margins of error that they specify in each of the groups of for a network of measurements. So yeah, and I'll read that out. I did cover that. It's on page 62, just above the triangles, the chart of the triangles. The mean error of the angle is plus or minus 0.87 arc seconds, and the probable error of the same is 0.59 arc seconds.
Okay, so this is what I'm saying. These are not addressing this other margin of error that I'm discussing, right? Which would be the maximum difference between the intersections, because that's obviously pretty important. If we're going to take an average of it, and then the average barely pops up over 180, right? I mean, that doesn't look too good. It actually seems to look bad to me.
Well, and to your point, and I covered this with Shane, this particular, they're not doing spherical excess as any proof of the globe. That's not why they're doing it. They're doing these things so that they can measure the length from one side of the United States to the other side of the United States.
Yeah.
So,
yeah, for sure. Like they're not like trying to prove flat Earth wrong, right? Like they're just assuming the Earth's a sphere, and they're trying to take our current plane survey data, and they're trying to further.
No, this is before any plane surveying data was done. This is the primary triangulation across the United States. So you do your
George
primary.
Washington did plane surveys, man.
Yeah, you do your primary. You do your primary, and then you come back and then others come back later and do secondary, tertiary. And the different state plane systems integrate with them, and every single one of them has has adjustments because they're none of the surveys are exactly the same. And different things have to be adjusted. And specifically when you have these plane surveys, they have specific ways that they do adjustments when they map between the plane survey, because there's errors if they're over a larger amount, to the actual things like the NAD 38, NAD 83, NAD 26, I think is the one, and NAD 88.
Okay. So, yeah, like I said, I just started looking into this a little earlier today, and I do think that we may have just let you guys slide on it because we call you out for the spherical assumption.
Austin, I sent you this 2 years ago, I think, first.
Yeah, but I called you out for the spherical assumption.
You've kind of been slacking, Austin.
Well,
come on, man. 2 years ago, you didn't look.
I think you're scared. I honestly think you're scared. So, like, the reason you got ignored was because you guys couldn't honestly address the spherical assumption bit. But we'll get to that in a second.
There's no spherical assumption here.
Well, I just read the paper that blatantly says there is. Okay. So, but this is the point, right? When you say there's no plane survey data, of course, well, yeah, actually, there were small increments of survey data. George Washington did many surveys. Okay. This is how they knew distances or approximations of distances. This is, of course, like you said, they're not trying to prove flat Earth wrong or something. They're just trying to integrate the actual measurements of the topography into the model, the ellipsoid model, right? So they have like an ellipsoid consideration, it's called. Like they're considering the Earth an ellipsoid. Let's figure out how the data will integrate into the model and we can get more accurate. And of course, this is actually expressly explains that this is built upon many other surveys. Like this was done over the course of years, and it's connecting many other surveys as its foundation. It explains this at the top of the page.
Yeah, it has, especially on the East Coast, it has several different triangle nets that they've used. In fact, the very first one here, and this, I don't know if this is the first one here. This tail, I think it is. But the lengths that they did, because they need to measure lengths, typically when you do a survey like this, you get one side of a triangle that you actually measure linearly, and they used specific, I forgot the name, but it's some I think guy from the Netherlands or Sweden, I don't forget. Anyway, developed an 8-meter long rod. And they had 4 of them, and they used those end to end to measure the distances of the first length. And it took like 45 days to measure 8 kilometers. something like that. And they include things like there's a thermometer on each of them so that they can get the coefficient of thermal expansion for each of those rods and include that in their measurement. So they're accurate to less than 1/10 of a millimeter.
Okay. So anyway, like when I'm looking through this, what you find out by glancing through it, like I said, I'm going to look more in depth to it, but clearly as the distances increase, the spherical excess increases.
Yeah.
But it isn't like this proportionate increase directly accurate with the radius or anything. It's actually not that, but it does increase as you get bigger
Austin,
triangles.
Have you not looked at my spreadsheet?
Yeah, I know that you think that it is a perfect progression, but it's not, because what happens is the corrections are also increasing. As I'm looking through it, the corrections are increasing. So, and we're gonna get to the bottom of it. But what I think
Austin,
right now
hold
is
on,
that
Austin,
the
let me
fundamental
tell you,
disconnect here.
the corrections for the final one there that I mentioned, not the final one in the book, but on page 218, the correction is 0.07 arc seconds, 0.115 arc seconds, and 0.455 arc seconds. The corrections are actually right in the same neighborhood as at the beginning.
No, I saw some that were definitely more. So this is one thing for sure, though. You're going to decrease the accuracy of your optical measurement as you increase distance, right? Obviously. And
but Austin, there's only 360 degrees in an azimuth. They have the same checksums. That's the beauty of how they're doing it. They have all these built-in checksums.
So what you've done is you've taken the actual numbers and you're like, look, this is just the raw data, and the numbers show you that it has to be a globe. But when you actually start to read through it, you find out that the way they get the numbers that are even on the chart have spherical assumptions baked all throughout them. You ignored the first one that I read, and we'll go back to that in a second. But another one, right? The central section, which extends from Big Springs, Colorado, eastward as far as St. Louis, Missouri, over a distance of about 1,200 kilometers or 756 miles, partakes of the very opposite character from its neighbor with respect to width of development or average length of sides. The latter is but 27 kilometers or 17 miles and is therefore a minimum value. This feature was imposed upon it by the general flatness of the Great Plain, which lies between the eastern slope of the Rocky Mountains and the Mississippi River, descending very gradually from about 1,800 meters to about 135 meters or 443 feet. So then it says right here, this proposed arc may be considered as complementary to the arc of the parallel, one giving a measure of the curvature in the north and south direction, the other in an east and west direction, thus affording within the limits of the country that means for determining and oscillating a spheroid closely approximating to the curvature of the Earth's surface, which is why when we get over here, I'm trying to actually get to the truth, right? I don't have some motivation to just defend this. You may, right? Just been on your website for a while, but this right here says specifically, it says to derive the probable error of an adjusted angle by the rigorous method involves so much heavy computation in solving the various weight equations that one is forced to use some approximate formula for computing it. Although observations upon different signals have been given equal weight in the adjustment, it is nevertheless recognized that a difference of accuracy exists and that it is desirable that it should be taken into account in computing the probable errors. This may be accomplished to a certain extent by making the computed probable error for each direction depend upon the residuals from that direction only, instead of basing it upon the whole group of residuals. So it's very clearly saying that it requires such heavy computation to solve the equations that one is forced to use an approximate formula for computing it. So this is obviously what it appears is they've built on many other surveys before this, and it explains that they're getting better at the methods and they're working on it. And they had to make a lot more guesswork back in the day, and they're using base formulas, spherical corrections at the base of how they're actually putting down the data. So it's this narrative that they're going out there and just taking the data, going straight to the page and just randomly doing the average and it works out to be a sphere is not what the paper says. It's not what the paper says.
All right. Well, what you've identified, Austin, is that there is a margin of error and they are doing things to increase their precision. But it seems to me like you think that the corrections that they did are intentionally being put in to output a specific radius of the Earth. And if that is the case, then I would love for you to show the math where that happens. Right? So
No, he didn't just
because
read a
because
margin
when
of
you,
error.
and this is important, because in that spreadsheet, that's why I asked if you'd seen that spreadsheet, on the second sheet number 2,
the radius is pretty close. Yeah.
It uses the spherical excess and the lengths of the sides to output the radius in 3 times for each particular triangle.
Yep.
So if they are faking it through those corrections, then you go right ahead and you show where they are faking it by forcing the radius of the Earth in that. It's all there. If they're doing it, you will be able to find it in the numbers and in the math.
And I think actually, even though you paint this narrative that I'm not good at math, I think you actually know I am going to find it.
I think you're terrible at math, Austin.
I know
not
you
as
think
bad
that.
as Brian Leak.
Yeah,
but I don't think you're very good at math, Austin.
But I don't care. I don't care what you think.
Prove me wrong, please. Please be better at math than I think you are. Go ahead.
Okay, great. Now, this is the point. It says very clearly that they have a specific way they do it that is assuming the sphere at the offset. And then even is with things as much as sea level. There are approximate corrections for sea level prior to anything else.
Just
even
show
taking the elevations and comparing
Austin,
the measurements with the
just
elevations
in this particular thing. If it's because I've isolated the raw measurements and the corrected measurements, we're just looking at that, right? We're isolating that. And so the only way that you could output a consistent radius is if the corrections that they put in somehow included the radius, and the numbers are there, the data is there, and if they're doing it, then it will be found.
Yeah, you're right, because it says that it's built upon the other survey data, and it says and it acknowledges and invokes certain methodologies that was built upon, and that all this data is built upon it.
This is the third time you said that.
So we're just going to go back to that, and when I read it right here, it's saying that you have the measure of horizontal angles of the triangulation being completed, and that there's a reduction of observations and a preliminary computation of positions were kept abreast with the field work, but some unavoidable delay in the final adjustment and preparation for the press occurred and the consequence of the late supply. So it's describing right here that it's making adjustments for sea level, and that it's built upon.
Like I said, show where, because this the isolation that we're talking about doesn't have any sea level included in these.
Because this is, dude, all of the data that the only data you want to talk about is the data they put down built upon all these other calculative assumptions.
So you say.
So you agree that if that's the case, then you have to walk it back and take it off your website.
Show it. Show the math.
Okay, just to clear, I'm going to. Just to clear, not right now.
Go ahead.
Because if it's not there, then I'll happily say it's not there. But you would admit that if we find out that the way that they actually, get sea level and they make all kinds of preemptive calculative assumptions and corrections built upon a spherical assumption, then this isn't proof of anything, and you need to take it off your website.
If you find,
why isn't their words enough for you to be convinced that when they say in their paper that they're presupposing the sphere, why is that not enough for you? You don't believe their testimony about what they did in their measurements?
I don't know why. What that has to do with anything, because this specific thing that we're talking about is
what do you mean?
These spherical axis measurements.
Excuse you. I'm not an idiot. I spoke directly to the subject that you're speaking about. Why do you not believe their testimony about their calculations that you appealed to that Austin just read?
Because that's not specifically talking to the measurements that we are addressing here.
Yes, it is. It literally is.
Then the math
explains
then you will be able to show the math.
Applicable at lower and equal elevations require modification when great inequalities exist in the heights of the stations.
Yeah.
For the first time, corrections have been introduced for the variations of latitude. Right down here, when it says the first time, it means compared to the other data it's built upon. Right down here, it explains that we have a lay supply of the height measured required for reducing 2 of the principal baselines to the sea level. Measure of horizontal angles of the triangulation were completed, and they reduced 2 of the principal baselines to the sea level. So it's literally explaining.
Excellent. Well, Austin, like I said, I don't know, 3-4 times already, show where they included the radius of the Earth to force these spherical axes to match. Go ahead.
So you see how you ignore my question?
Yes.
You saying show me where they did that
He said
demonstrates
Yeah, I'm ignoring
on
you,
its
Gregory.
face that you
I'm
don't
specifically
believe
ignoring
their
you.
testimony
Yeah.
as you, right.
He said yes.
Show me the math. That's all you need to do. If you think it's there, if you
He
think
said
that they faked it, show the
that
math.
I'm ignoring you,
It's
Gregory.
right in there.
So this
It's
is
right in there. Go
bigotry.
ahead. Show it
He
up.
has to suppress my voice to talk to me.
Moderator.
So what I was saying, right? That's why I asked the question. You sit here and you demand, show it, Austin, is demonstrating that you don't believe their testimony about what they're doing that he just read, which you appeal to. Why?
You just need to show that they actually forced the radius of the Earth into those measurements somehow. And it wasn't
Okay,
just.
dodge the
So if
question.
you can't do
Anyway.
that, then you have no point. And Austin
Okay,
agreed to
now
that,
you
and I think that's
again.
fair.
So I've already found one of the main ones, which is that they're actually
Show
how
the
do you
math,
think they
Austin.
corrected for sea level? How do you think they corrected for relative sea level, McToon?
Show the math,
without
Austin.
knowing the radius.
Show the math, Austin. That's all you need to
How
do. You
is
are
sea level
assuming
the same
you're
on a-
assuming that they're baking into these azimuth measurements, that they're baking in the radius. You just need to show it.
It literally says in the first paragraph of the paper that it's built upon the prior, and it says them by name, which is, I'm going to look into them. I'm going to do it. So it's built upon the prior surveys that you haven't even researched yet. I don't know why you're so overly confident it doesn't have the R value. Do you agree that a sea level is different on a globe and on a plane?
Yeah, they have a
This
different
is so
shape. They have
patently
a different shape.
dishonest. He,
Right,
he obviously refuses to believe their testimony about their calculations, but he still has the nerve to appeal to them. That's dishonest.
So if we're going to use sea level, right, and elevations above sea level compared to one another to establish height, then obviously we're going to have to make a spherical application for that to happen, right? Like we're obviously going to have to differentiate between just using an infinitely extended horizontal sea level.
Yeah,
Just
like I said, again, what was this, 5th time, 6th time? If they are baking in the radius of the Earth in those azimuth measurements and the corrections, just show where they're doing it.
And I just want you to say on record for everyone that when I show that that they corrected for sea level based on the previous model, which all the other surveys also had final R value products, McToon, you will take it off your website.
Austin, you need to show how they baked in the radius of the Earth into the azimuth corrections. That's what I'm saying.
Okay,
so that's your
they
claim,
baked it into
right?
the way they actually took the measurements. That's what you want
All
to keep
they have,
avoiding.
Austin, all they have is azimuth measurements. There's 360 degrees in an azimuth. They can't bake that in. It's a measurement. There's 360 degrees. You can look at the triangle nets. You look at those nets, and if they somehow faked it by adding more degrees at any one particular one, that's not a straw man, Austin. If you think that they're faking it, you need to show where the data where they did it.
Okay, but you have a narrative because you know it's a safe bet. Like that's why you're straw manning me, as if I'm
It's
saying
100% safe bet because the Earth is a globe, and you're never going to find the math that forced it in, Austin. 100% safe bet for me,
my dude. You're straw manning me just to make sure you have a safe position, because I don't think there's a scenario in all of existence that would make you walk back the last however many years and take this off your website, right? But
you would just need to show that they're faking it, Austin.
I already read off what they said. You ignored all of it.
You don't understand what they're doing, Austin.
Oh, then correct me.
This is top left, Austin. This is Dunning-Kruger, Austin.
Do you understand Dunning-Kruger goes both ways?
Of course it does, Austin.
Oh, you use it a lot. You don't seem to understand it. But so I'll read it again, and you'll ignore it again. to derive the probable error of an adjusted
gosh,
angle by
again.
the rigorous
You already
method
said it,
involves so
Austin.
much-
You
You're
already
ignoring
said
it.
it.
You're ignoring
Show
it.
where they
I'm so
force
top
the
left,
radius
why are you
into the
ignoring it?
azimuth measurements. Go ahead. Just
Well,
show
why are
it.
you ignoring my point? This is your own paper. This is
Because
from
you
your
are
website.
asserting that based on what you're reading that they did some specific math and you have not
Well, what I'm
shown that
saying is
specific
that
math. So show the math. And I know you won't because Austin, I don't think that you can do the math.
Okay, then prove me wrong right now and go to page 40 and show your audience what I'm reading since you're so confident. But you
I'm
won't.
talking
You
about
also
you.
won't.
Austin,
You 100%
missed the
won't go to
point.
page 40 for the
You are
audience.
asserting that they have
Why are you
faked
scared?
the radius of the Earth with the math.
Why are you scared to
All
show
you
the
need to
audience
do is
page 40,
show
bro?
where they faked the radius with the math. I'll bring
It
it up.
seems weird that you're scared to show the audience page 40.
Is that the straw man you're talking about? Is that the straw man you're talking about? Because McToon has repeatedly said, Austin, show us that they faked it. Instead of being charitable in the interpretation of what Austin's saying, because what Austin is really saying is that they didn't necessarily deliberately lie, but that they made these calculations and their calculations is fallacious because they're presupposing the globe.
I 100% know
the
they
math
didn't
is
lie.
wrong,
I don't believe that anyone
show where it's
lied.
wrong.
I don't believe
Then
they
you just
lied.
need to show where it's wrong, Austin. That's it.
Okay.
If
So
you think
to
that
derive the
it's
probable
wrong
error,
math, hold on. I'm bringing it up. Page 40 of the PDF or page
because I don't
40
even
of
know
the
what I don't even
publication.
know. That's what I'm asking. Like I'm
Austin.
not.
Are we still
Austin.
waiting for witches to do some math?
Yeah, we'll be
They were
waiting
waiting
on
on
that.
that, aren't we?
Did you have
We'll
a
give them time.
contribution,
We'll give them
Duval,
time.
or-
That one.
All right, Austin, page 40 of the PDF or page 40 of the publication, because the numbers, the page numbers don't match.
I think maybe publication because I've already scrolled up. I think it's yeah, right there. You see to derive.
To derive. All right, to derive epsilon, the probable error of adjusted angle by the rigorous method. Yeah.
Keep going.
So
involves so much heavy computation in solving the various weight equations.
You know what's cool, Austin? You could put all that computation into a spreadsheet and do it for them using the actual approximate formulas.
Here, I'll give you the intersection computations and formulas. How about that?
I'm just saying, since you're so much more in the know, can you tell us what it's talking about when it says that it's supposed to use approximate formula for computing it with heavy computation? Okay, I'm just trying to understand.
We're getting the PDF.
Well, there's the intersection solution.
All right. Where did you send that?
In general.
I'm not seeing it yet.
You got any more steel wool?
Oh, there it is.
Hey,
Okay. Well, Shane posted it. That's the wrong thing. I don't know. I don't see where you put it, man.
Wow, dude, you guys
general?
are all your
Oh, I'm sorry. Austin, hold on. I'm trying to get this. He put it in general. I was looking in the live stream text.
Yeah, I said general too.
Okay.
I prefaced that.
Sorry, that the intersection is all right. Very nice.
So that's the solution, and the equations are coming up next. So don't leave.
All right. Well, awesome, Austin. You there's your stuff. There's your stuff. All right. So I'm looking back to page 40.
So you know we're gonna get to the bottom of it, right, McToon? So
I hope
I'm just
you do.
curious.
Definitely.
I'll give you the whole PDF, bro.
Right. So I'm just saying, McToon, you agree, of course, though, on a fundamental, like, just intellectual honesty litmus test here, right? Like, if they're building this survey on all these other surveys, and within the surveys, they have integrated spherical assumptions of a specific dimension for the base formulas prior to taking the measurements, then this doesn't prove anything, and it's an affirming the consequent.
Absolutely disagree.
Oh my God.
Because
That's
when
the
we
case, and there's no
isolate
point in debating, if you can't follow that line of reasoning hypothetically, what's the point?
Come on, man. You gotta let him talk when he talk. I mean, you're welcome to.
When we look at just the spherical excess, because like I said, they weren't making a point about spherical excess. We are zooming in on that particular thing. When you look at the spherical excess, they use They use an azimuth measurement, and all of the azimuth measurements of all of the triangles at any one point must sum to 360 degrees when you go all the way around. That's their checksum. If they intentionally added some, which you'd have to intentionally add if the Earth were flat and you had to force that the Earth was spherical, you would have to intentionally add some numbers in there somehow in order to force every one of those triangles to come out to the same radius. Now, the specific math, maybe there's other ways.
Yeah, and I got you that. Listen, I got you on that because it's the computational latitude and longitude, which is based on a spherical datum.
Correct. And it literally says here, for the first time, corrections have been introduced for the variations of latitude.
That's right. Now I'm going to give you that. I've already posted the fucking... So it allows for curvature, meaning it's based on a spherical datum, and it's done within a spherical coordinates.
All right, I wasn't done. But fine.
Oh, that's fine, but...
Yeah, that's fine.
It'll be
Never
okay,
mind.
though.
Never mind.
And something else you guys misrepresent, you say has nothing to do with refraction, but right here it says, the laws of refraction applicable at lower and equal elevations require modification when great inequalities exist in the heights of the stations.
And you know why? Because they weren't just doing azimuth measurements. They were doing other measurements.
Oh, so they don't have to worry about the heights of the stations varying due to refraction.
You do on the other measurements, but not on the ones that we're talking about.
Are the other measurements factored into the final product?
Not of these particular ones that we're looking at.
Are
Remember,
you
we're
sure?
zooming in, Austin. We're zooming in on just these azimuth measurements that output the spherical excess.
What about the resection solutions?
I don't know.
Based on the coordinates, each station is at a certain coordinates within a system, a coordinate system, which is a datum. And I know you could name all the datums, which are spherical in nature.
So they're based on spherical coordinate systems, but they don't assume a sphere?
They do, actually.
Well, the survey absolutely deals with that because they know that the Earth is a sphere. But like I said, we're zooming in just on the spherical. Like I said, we're just looking at the... Oh my gosh.
So did you get those spherical computations that you asked for?
Hey,
McToon, can you tell me what this means?
One question at a time, please.
All right,
Let him answer before we just start scattergunning.
My bad.
I'm in the middle of this, and it's difficult to capture all of these things that you're sending. If you could DM them to me, then I would definitely have them. Otherwise, just putting them into the general chat, I'm gonna miss them.
Well, all you got to do is download the PDF, and then every screenshot I gave you, you'll have.
Well, you know, like, why would you
everything that we did about
This is
them
what it's for, to not go in general and have this exact thing happen, Mike? Like, I don't know, man.
What's that?
We have this live stream. Only people in the call can use the live stream text. Why we would deviate from that to show someone else in the live stream something I don't understand.
I agree.
What is fun? Hey, McToon, can we clear something up, man? Do you think that I
just
truly
send it in
believe the
your
Earth is
DM.
flat?
Hold on a second. Austin. Michael. Did you post it? Can you post it in the...
I'm just going to put it in your DMs.
Okay, perfect. All right, Austin, what was your question?
Yeah, just to clear it up. Do you think I truly think the Earth is flat?
Yes.
Okay, so then all these crazy people in your chat that always say that I like intentionally lie and I'm a con man and I know it's not flat are kind of crazy, aren't they?
I do not agree with that position. And for reference, I used to think that Jaron didn't think that the Earth was flat, but after talking with him, I have changed my stance, and I actually sent him an email just 2 days ago, I think, clarifying that to him. I mean, I already mentioned it before, but saying that and apologizing specifically to him that I do think that he thinks the Earth is flat. That I agree with it, but I specifically said, hey, Jaron, I'm sorry, I misread you, but since we've spoken, I've changed my mind, which is, so whatever.
Okay, yeah. No worries. I just think it's funny. I just think like how toxic some of your followers. I mean, that's not you, right? Like it's not your fault or something. But I have people that are probably toxic much anyway. Okay, so but what we figured out already is that they actually use base spherical coordinates and they actually make this is the first time out of all. So they built on these other surveys. This is the first time they had first time corrections introduced for the variations of latitude, which are of course spherical coordinates. So at the offset of their actual survey, they are using spherical coordinates and latitudes. Now, how could they have spherical coordinates for latitude if they didn't have an R value?
They had the spheroid values of Bessel and Clark.
Yeah.
And on page 19, they note that their measurements in total do not fit the Bessel ellipsoid and do not fit the Clark 1866, but an intermediate value. So all the data they presented in this report, they present all the raw data and their adjustment. You can take all their raw data and run your own adjustment.
A good try. Unfortunately for you, I read that part. So how much different was it?
In measuring across the 4,200 kilometers, under the Bessel, it was 615 meter error.
Exactly. A 615 meter difference out of how much?
Between and on the Clark, it was 200. But by this measurement, they get 26 meters. So they were developing the A and B major and minor axes of the ellipsoid that fit the North American continent.
Yeah. So you had a completely useless input, and you specifically didn't specify the amount of difference intentionally, as if to mislead the audience that there was this huge difference and they were just coming up with their own raw data to make their own coordinate system. But no, that's not what it says. It says it's built on the other ones, and then it tried to correct any errors, and that out of 4,224 kilometers, there is only 26 meters for the probable error of the measured length of the total arc, whereas the difference between the arc of a parallel and latitude 39 degrees on the Clark and on the Bessel spheroids is 615 meters out of over 4,000 kilometers. So when they use their actual latitude corrections, how are they going into the observation or the measurements and
Austin has discovered that measurements get better over time.
You can develop your own conclusion. They ran an adjustment
I think we have
the integrity of the data, and they saw that it doesn't really fit Bessel all that well.
It's pretty damn well, actually. It says it's actually bragging about how well it matches.
The North American datum of 1927 is not based on Bessel for this reason.
It doesn't matter. They're actually in the paper bragging about how much it does match. And you see if you can answer my actual question. If this is the first time that they introduced first-time corrections for latitude, how are they going into the measurement correcting for latitude?
Astronomic latitude versus geodetic latitude.
Okay, so when we have astronomic latitude, does that give us a rough estimate of an R value?
Yeah, well, the A and B axes of the ellipsoid, because an R value, there is no specific R value on an ellipsoid. It's instantaneous, and you have an effective radius over short distances, which is an average of that. But over a very long distance, it's not a radius because it's an ellipsoid. You have a geodesic.
Okay, so they are using an effective radius with a spherical coordinate system of latitude.
And they provided the raw data so you can develop your own.
Yes, but actually in the data, they explain the correction formula they have to apply to things such as sea level and latitude.
Which is why they provided the raw data and their adjustment, which is considered preliminary. Throw their adjustment out. Ignore their adjustment altogether. You figure it out. They provided the raw data for that reason to the academic community of many nations.
Okay,
well,
so you're just
astronomical observations, Odup, are about true meridian, right? Which is based on a continuous circle, right? Is it not?
Well, that wasn't in his script, bro.
Right. It's a circle of constant latitude or longitude.
And astronomic observations,
but they're meridian and they're separate from latitude.
Being able to quantify in this survey here, they're actually being able to make meaningful measurements of the deflection of the prime vertical by
Why are
the
you ignoring
integrity.
this question?
Restate the question, please.
Why do you wanna? What was your question?
Yeah, I'm confused now too, bro.
Ask your question again. He wants to answer it.
Oh, I don't think he does.
State it.
He was
Which
asking about the meridian, the relationship between meridian and
Oh.
astronomical latitude.
Yeah, so the astronomical observations are about meridian, but the computations for longitude and latitude are separate from astronomical observations.
Astronomical latitude and longitude prior to, mid 19th century was all you had, was what the technology was available. And by the integrity of this survey, they can make a meaningful measurement of the deflection of the verticals to quantify the difference between astronomic observation and a geodetic observation.
Okay.
As the ellipsoid is refined.
Right, exactly. You're right. So they're trying to refine the ellipsoid by starting at a base foundation. Now, within your guys' paradigm, right? We've had longitude and latitude for a long time. They've actually got within like incredibly accurate radius and circumference values long time ago. So this whole idea that they just went in there like cavemen that got hit with men in black guns and knew nothing and were just completely honest and raw with the data is a joke. They actually had preemptive corrections for latitude going into the measurements, right?
Yeah.
So they had
wait a minute.
systems of latitudes. This is
That's
the first
the elephant in the
correction
room.
for latitude, and they were trying to-
That's why they provided the raw data. They did make an adjustment, and they published that simultaneous with the raw data, and so you can develop your own, make your own evaluation of the data in aggregate.
Really? Okay, so please tell me specifically where's the raw data for the where it says that there's so much heavy computation in solving the various weight equations that one is forced to use some approximate formula for computing it. What's the raw data for the approximate formula?
Raw data is presented under the column
formula.
headed observed.
The formula.
Approximate formula. I want to know.
No, observed. No, the one. No, observed.
Yeah, how
Observed
do you
data.
That's not what it says.
Listen, we're asking about the computation of the observed data to fit the datum, and we've already proven that.
And you can throw out their computations. Do your own.
We've already proven that it's been said this isn't based on a spherical datum, but we've already proven that it is. It's assumed spherical in this survey.
They made preliminary adjustment on the vessel. They were going with the vessel.
Yeah, I wasn't done talking. So my point was, we've been told that they measure spherical triangles, but what we're seeing is that they lay these spherical triangles out on a spherical datum. And that's a computation and the correction and the reselection correction and the intersection correction. They're all about adding in the spherical axis. Adding it in. Yeah.
And all data has nothing.
If they added it in.
And you are free to discount all of that and just go with the column headed observed and do your own computation on the entire data.
Raw data has nothing to do with the heavy computation being solved with an approximate formula. The fact that you keep responding with raw data shows that you don't know what you're talking about.
He's spiraling.
Wait, Austin, you're telling him that he doesn't know what he's talking about? That's cute.
That's right.
That's cute.
Because you can just read the words
it's
here
beautiful.
and see that
That's
Obviously,
top left.
Obviously, you didn't too, because you've
Top
been
left.
silent since you were showed the computation equations for spherical.
Oh my gosh.
Yeah, and you told us it had nothing to do with spherical assumption.
Yeah,
It doesn't. Yeah, the raw numbers of the azimuth angles and the corrections. Yeah, you go ahead. You keep saying you think that they baked it in. You just show it. Just show it.
Discount their corrections. Discount their corrections. Take the data, head it as raw observed, and do your own computations.
Okay, so then you guys agree with everything, and you'll stop bringing it up as if it's
just do it.
Listen,
Stop puffing your chest, Austin. Just go do the math.
Listen, the entire point of this conversation that was to prove that spherical math is used to equate this, and we've already proven that. You have an understanding with your fear, buddy.
You can
more basic from Earth is life, of course.
They provided a least square adjustment of their data to show the demonstrate the integrity of the data. You can throw away their least square adjustment and do your own with the observed data.
Now
No,
you're just repeating
man. You guys want to keep straw manning us, saying that we are questioning.
The point has been proven,
data,
bro.
that we're saying that they're lying, and because that's all you got. When actually, what we're pointing out is the very methodology itself is affirming the consequent. It's actually built upon
what specific methodology of the observed angles and the corrections is the problem. Just show it. Just show
I
the
already
specific.
showed it to you, and it's a computation per longitude and latitude, bro. How many times? I don't like to repeat myself.
How's there a
do.
longitude and latitude in an observed angle?
That's only past the point every time articulated.
Can we do one at a time, guys, please? Anyone?
Well,
yeah, but they're getting kind of nervous. They're interrupting.
It's a computation of longitude and latitude.
We are too.
Exactly.
How did they get the computation of the longitude and latitude into the observed angles?
Because that's where, dude, they
listen.
from a
They
certain
apply it
position,
to the angles.
Duh.
They make those angles adhere to the longitude and latitude, which is a spherical coordinate system. You're just spiraling.
All right.
I really love how.
So it sounds it sounds like you think that they're baking the radius into that. All you need to do is show the evidence.
I really wish you would have just read the PDF. I already gave you the evidence.
Well,
and you're deflecting.
Hard for you to believe this, but I haven't had a chance to read it yet.
In their calculations, he just read that. So you keep blurting this objection back out. You are just demonstrating you don't believe what they said. This is dishonest.
Yeah, don't read the equations, bro. Then you can. Ignorance is bliss.
And dude, you're you were talking about Dunning-Kruger and cognitive dissonance. Like, just read your chat. It's wild. But so what we're actually talking about is that when they make their observation or their measurement, right? It's from a certain position, and the way their foundation is they use the spherical coordinate systems with correction to latitude,
and they build this into the observed angles somehow.
The measurements.
How?
Going into the measurement.
Step by step. How did they build that into the observed angles?
Well, that's what I've asked 5 times because I have to research it more. I don't put it on my website and brag about it for 5 years though. So it clearly says that's what they do.
So you're asserting they did, but you don't know that they did.
It says that's what they do. I read it out loud.
No, the observed angles, they didn't bake in the radius there. They didn't bake in latitude, longitude to the observed angles. Austin.
This is
nobody said bake. I said computate. That's the
into the observed angles.
Proper.
Into the observed angles. So you computated into the observed angles the latitude and longitude.
I'm going to finish my sentence when you're done talking. Well, it's part of the process of triangulation in survey. So you computate it. That answers the question. You correct for it. Longitude and latitude, which is a spherical coordinate. So you don't know what a correction equation is?
Why would you have to correct for it, though?
Yeah, that is the big question.
That was awesome.
Real question: is it baked into the observed angles? Is the question, and the answer is no. In their methodology,
our surveyors bakers
in the methodology that they lay out? The observed angles are not where the corrections go.
So you don't believe what they said about their work, then?
Oh man.
That's what I keep hearing over and over again. I'm a simpleton.
Fantastic. This is amazing. The corrections are in their own
math whiz.
Maybe you should sit out.
This is great. This
Don't
is amazing.
project so much.
Maybe you should shut up.
Okay. The corrections go in their own separate column. The observed angles are prior to correction.
But you keep categorizing them as corrections. That's not what they said, as Austin just read.
Austin, how long have you been researching this?
One
day?
The column title is correction.
Reread it.
Certainly a correction.
Nice implication, guy.
Well, it just actually that makes you guys look bad.
It does. I had to give him a PDF on how the process goes.
In fact, I've been looking just for a couple hours, and I'm super busy today because I'm leaving town tomorrow, and I am just destroying you guys because you guys literally lied about there being spherical assumptions baked all into every single aspect of it, and now you have to mute me and interrupt me and censor me because
you just keep going around, but you can't answer how they baked in things that you're saying are baked into the observed angles.
It's been. Are you a magician? Do you think repeating this over and over again is going to save your position?
Yeah, it shines a spotlight on the failure.
I'm done.
That's what I'm doing.
I'm
shining a spotlight on the failures of your claims. Austin
Yeah,
and Michael.
it's
That's what I'm doing.
delicious.
The observed angles are observed angles. They can't
Dude, you're giving me a great laugh.
They can't bake in latitude and longitude to an observed angle.
Okay, I'm going to be specific about this now. No, I didn't say they baked in anything to the observed angles. I say they correct for those angles, and that the
Okay,
correction
is that
based.
in the
Can you let me finish, or do I have to mute you?
Yeah, go ahead.
I will mute you because I'm fucking tired of this. So when you computate for correction, that means you make this observation go along spherical longitude and latitude. You're correcting it to match with longitude and latitude. Because each station has a specific longitude and latitude, which is the spherical coordinates.
If it's flat, why are they correcting for it then? They shouldn't have to.
That would, yeah, you'd output a bunch of errors then, wouldn't you?
It's the other way around, B-ball, but okay.
He did that 2 times in a row.
No.
Yeah, that's the dumbest question I heard yet. That's why I haven't.
All right, so Michael,
you're literally switching around the positions, like literally with that blur.
All right, Michael.
Oh man,
Dude,
don't
this is wild.
pay that dude no mind. Listen,
Michael.
the name thing don't bug me. It doesn't bug me at all, Michael.
So
I'm not Austin.
What
I
about
won't get triggered. I'll just wait till you're done with your spiraling, and I'll finish my sentence.
what about the formulas that BattleMod provided? Can we address those? I like those.
That's all bullshit. Let's just walk around them and repeat ourselves and be redundant and think we're doing something with our
I think we should go back. I think we should allow Larry to talk because he's the one with the most experience in surveying.
I don't think so. How do you
Literally
know?
never
How do you
said
know?
anything of
How do
value.
you know I'm not a certified civil engineer or highway engineer? How do you know that?
Well, then you should probably give your certification back if you think the Earth is flat.
There you go.
Oh, well, that's nice. I probably got more money than you. So why don't you just mute yourself so I don't have to mute you? Cool?
That's cool.
Cool.
That's cool.
I got more money than you.
Shut up. Yeah, so shut up now.
Oh my gosh, what
You
a
guys
loser.
you make the global. If the Earth's a globe, you make it look really bad.
I mean,
All right, Michael, I have a question. Michael.
For a day, and you think you're a fucking, you think you're an expert at it. That's why
I
you're.
literally said explicitly I'm not an expert on it.
I literally said shut up.
I have a question for
I mean,
Michael.
what? I mean, wow. Like, because carping is
God.
going to defend your position.
Let's hear the question.
All right, Michael. We have there's only two angles that we're looking at. We have the observed angles and the corrected angles.
We're not talking about them. We're talking about the corrections for it, for longitude and latitude.
Okay,
You're
well that's all I was
you're
that's all
on-
I was talking about. So
Yeah,
you,
I know.
you talk about something
So
else
we
then.
take
Okay.
we take an observed. No, you're trying to say these raw angles don't do nothing, but you don't find spherical axis or the parallel of the arc until you calculate or correct for longitude and latitude, which is the spherical coordinates.
I don't know.
Then there becomes
I see
axis.
the 60. I'm muted on there, so I see the 62.16.
I gave the equations. I gave
right there.
the PDF. I
Raw
showed the
number.
process. You just keep
Raw
flapping your
number.
mouth.
All right, so I'm confused then, Michael. If we're looking at page 218, triangle number 28, it sums the observed angle sums to 62.16 spherical excess. So
It doesn't show the computations in the log, does it? It just shows the log.
But so are you saying that those particular numbers have had some modification to them and that they're not the observed angles, that they're something else?
Yes, I'm saying when the process requires that you correct for longitude and latitude before you log your numbers, you do that correction. Yes, that's how survey goes.
In the observed angles, they had to include the latitude, longitude.
It looks like you haven't read all the stuff other than the charts,
Austin.
Yes,
Step back.
I
I'm
said
talking to
yes.
Michael. Okay.
Yes.
So now latitude and longitude alone do not include the radius of the Earth, correct?
No.
Okay. So even if these observed angles somehow included, I don't know how, I don't see how they do it, because they have to sum to 360 degrees when they go all the way around in their circle. But if they somehow included modifications of the observed angles based on latitude and longitude, how is it that it still outputs the radius of the Earth consistently across all of these triangles?
Well, the astronomical observations are based on meridians and positions and points. Then there's computative corrections for longitude and latitude, which together form a spherical coordinates. I'm just repeating myself now.
Sure, but you already said that there's no radius in that.
No, I said no, meaning no, I don't agree with you. So you just kept on talking because you thought you had a position, but you really should have read the PDF that I gave you because you're talking about things you don't know about.
Believe it or not, I haven't had a chance. I'm still in the middle of a debate. It'll take time to read through it.
Yeah, a quick look.
After the debate, I won't be looking at it now.
Process.
No one was forcing you to talk. What are you on about?
Are you going to take it off your website?
No, this is demolition of flat Earth. This absolutely falsifies flat Earth, top to bottom.
That's definitely what you claim.
McToon, did you hear me?
No, I didn't.
It says in your little paper there that for the larger triangles, they have to take the radius in consideration.
In the observed angles? I'd love to see where the observed angles includes the radius of the Earth somehow.
And then you'll take it off your website.
Go right ahead.
You can't even answer
Yeah, if the observed angles somehow includes the radius of the Earth, yeah, you bet.
So, and like you agree that obviously you have to use a spherical coordinate system to have longitude and latitude going into the measurement?
No, because the observed angles are raw numbers that don't actually include, don't necessitate.
Is there a name for this fallacy? Is it what the magician's fallacy, the reiteration fallacy? I mean, I don't. Good Lord!
All right, thanks for interrupting that.
So my question.
So the observed angles must sum to 360 degrees in these different triangle nets.
I just got to repeat myself,
yeah. You just need to show where the radius was included in the observed angles.
But do you agree that you need a spherical coordinate system to have a longitude and latitude going into the measurement?
No, that's a begging the question there. That's a loaded question because an observed angle doesn't require latitude longitude, right?
Loaded question.
And there's no
question.
And there's no radius in latitude longitude.
If you think that was a loaded question, then you've actually subconsciously conceded that your point is wrong. But,
no.
Maybe watch it back, think about what I said, and then you'll realize it.
All right. Well,
yeah, so can I ask you again? Can I just ask you again? So, like,
no.
Do you agree?
Let's move on, Austin. You've beat this. You've beat this enough. And I'm waiting for your math. I will anxiously wait for your math. I'm sure Michael J. Smith will be happy to help you to show where somehow the observed angles, the corrections in the spherical excess included somehow the addition of the radius of the Earth because they all output the radius of the Earth consistently.
The last of the baselines was measured in 1897, but the determination of the heights of the Rocky Mountain stations yet demanded certain measures of zenith distance and spirit levels, which were supplied in 1898. In the same year, the last of the astronomic longitude determinations were made. Reduction of the observations, the preliminary computation of positions were kept abreast with the field work, but some unavoidable delay in the final adjustment and preparation for the press occurred in consequence of the late supply of the height measures required for the reducing two of the principal baselines at sea level.
Awesome. Zenith measurements. That's not what we're talking about.
Okay,
we're
so
talking about
are we
azimuth
establishing height? Are we establishing height, sea level, longitude, and latitude before we take our measurement? Yes or no?
Not in these particular observed angles. That they're not relevant to them because we are just doing azimuth angles.
So we don't need to know our position at all.
They know their position. They definitely know their position. But the observed angles sum to more than 180 degrees for all these triangles. But when you include the entire net, each particular point can only sum to 360 degrees. So if they are somehow forcing the radius of the Earth in, then the observed angles must be including somehow forcibly including the radius of the Earth measurements. And then somehow, if the Earth were flat, and yet they're getting 360 degrees when they go all the way around, how are they doing that? Where are they hiding that? The data's all there. I'll love to see it.
Well, actually, I go look at the data and I see all kinds of stuff right at 180 degrees. And when you claim it's spherical excess, it's right over it. I have all kinds of them highlighted. I've only looked through it for about 30 minutes. I've already found that the spherical excess is 0.01 arc seconds. Oh my God, there's the ball. 0.01 arc seconds whenever the admitted error is over an arc second. But no, 1 arc seconds over the admitted error is over an arc second. But no, 1 arc
Go back.
over
Go back.
the
Do the math.
admitted error.
Do the computations. I await them. I'm anxiously waiting for them.
That's his cavalry he repeatedly has fled to every time Austin has made a rebuttal.
Yes, absolutely.
Just repeatedly has
Because
fled to
Austin
every
is
time Austin has
asserting.
made a rebuttal.
Austin is asserting that there are
It's not
some
an argument.
somehow
It
the
is
radius
patently
has been baked
fallacious.
in somewhere. So all
It's
he needs to
patently
do is
fallacious.
show where he has done that, where they've done that. That's all he needs to
It's
do.
patently fallacious.
I'm unconcerned about your opinion, Gregory. He is asserting that somehow they have put the radius in, because that is the implication of what they're talking about. Somehow they put the radius in to all of these observed angles, corrections, and spherical excesses. Somehow, somewhere, magically done that. All he needs to do is do the math and show how it's done. Somehow, somewhere, magically done that. All he needs to do is do the math and show how it's done. Somehow, somewhere, magically done that. All he needs to do is do the math and show how it's done.
Okay.
Yeah, that was crazy.
That.
All right. It was a good point. I liked repeating it. Was worth it. All right. So anyway, I look forward to your math, Austin. Dearth thinks that you are the math guy, so I certainly he believes in you.
Why exactly do you think that I'm like inept when it comes to math?
Because you said you don't do math.
Well, yeah, so I don't. Yeah, exactly. Like I don't currently do math a lot. It's not like a profession I do or something. But you agree that aptitude and then like frequency of use are not the same thing.
Oh, certainly. But Austin, like
So
I said, prove me wrong. If you can do math, I want to see it. Go ahead.
I just want to know your opinion. Do you think I have an aptitude for math?
I think that you do not have the aptitude you think you have.
Oh, see, I think you know.
Not at all.
I
think that maybe when you were in high school, you could handle some of the high school math, but certainly I don't think you're very good at math. No. So, but hey, like I said, I'm open to being wrong on that, Austin, and you are the one.
Say that 'cause you've been saying it for so many years.
You are the one that can show that I'm wrong.
Word.
Okay, so like I was saying before, I was.
It already happened. It already happened.
This fallacious repeat cavilling where he says, "Go do the math," that doesn't refute or defend anything.
Well, that's kind of what they do, you know.
Well, Gregory,
it's a great day to whoop somebody's ass.
He has asserted that there are some particular aspects of this that the math will shake out, and so I just want to see it.
Yeah, the mathematicians who did the measurements said that themselves about their own work that Austin just read.
About different things than just the observed angles, though. Right?
No,
you're
even to
conflating
establish
the two.
level.
Yeah, you're
Even to
conflating
establish
these.
level.
You don't need to establish level to measure azimuth angles.
What datum did they work off of? Can I ask that?
No, I don't know, Michael.
Oh, I bet you don't.
But the observed angles don't matter to the datum that they used.
Actually,
you keep
it
going to
does.
this because when they measure observed angles,
when you correct for it, it does, and they actually computate for the spherical coordinate system.
So
the
then,
meridian, the longitude and latitude, that makes up the entirety of the spherical coordinate system. Come on, man.
Yes, and so then the like I showed earlier, Michael, the corrections that they did all sum to 0, so they're not. You
didn't show anything.
Things. It's page 58. It's page 58.
Are you going to look at the PDF you dropped? Are you open to maybe
during the debate, of course?
No, I know.
I'll wait on you. We can extend it. We'll call it overtime.
Nah, that's unreasonable.
I'm not done yet. I just don't partake in that ad hoc, ad hom bullshit. I'll let you guys do that. But I really like to talk about that PDF.
But Glober
when you get time
as well, right? They're like when they like drop a huge PDF and like, oh, you haven't even read it. You know, it's like that. But my point is, McToon, are you open to having maybe overlooked something?
Sure.
I love to read,
Absolutely.
man. I start reading that stuff as
What did
soon
it say,
as I
Mel?
get it. I'll debate and read at the same time, so that shit doesn't move me an inch.
I get that, but I'm just saying, like, I mean, it's not super long, but I mean,
What's it? You read every link I ever gave you, so I know you read.
All right,
Yeah,
Michael.
but
Here,
not
I'll
like
do this,
that
Michael.
very second.
I'll look at it, and I'll compare what you sent there to the process that it appears that they used in the survey here.
Yeah, well, that's a newer corrected process. Yeah.
Well, I mean, I don't care about the newer process. I want to know the process they used.
I know.
Right? That's
the
what
process
matters.
that was adjusted for longitude and latitude, right? That's how it became more precise.
As you said. So anyway, I'm happy to do that. And Michael, I would be happy then to reconvene after I've had a chance to look at these.
Well, you can come back every week just like FTF does. I'm here.
All right, cool. We'll get to the bottom of it, man.
All right. I look forward to it.
Yeah, and wait, real fast, because I'm confused about this, right? Like when I looked at it, I was looking through it. I saw where like the spherical excess, it would say like 0.01 arc seconds, and that doesn't prove the Earth's a ball. That's insane. Like, obviously, we need more.
Which one
than
was
that.
0.01?
I don't know. I have it highlighted somewhere. I mean, I couldn't
Well,
tell
the
you.
one
right
I
now.
used today was 1.23 arc seconds.
Am I supposed to be surprised that you chose the higher end and ignored the other ones?
I used the one that Brian Leakey used. I just used his.
I didn't know the context of this whole thing. And did Leakey drop that video today?
Yeah.
And then go drop it.
No, he dropped it a couple of days ago.
Okay, and then started this like thing because like he was very prepared. He added the addendum to get ready. He had already refuted like the basic. I was already uninterested when this whole thing started. I mean, like,
yeah, the one that he used actually had a spherical excess of 1.23 arc seconds, and you have to remember too that these triangles average about 10 kilometers on an edge. At least the one I looked at, it was 8.7, 10.7, and 13.4.
The only thing worth
page
pointing out.
93. Okay, and if you look at 2 and 7, you have spherical excess with the corrections. Then you go to spherical excess, you have 0.01, 0.01, 0.02. You come down to number 7 after corrections. You have 0.01, 0.00, 0.01. And of course, there are
kilometers with the legs on that, Austin.
0.00 after corrections.
You're looking at the ones with the margin of error with about like an arc second, right? Like 0.67 or something to 0.89. Like that was my first critique too. And it was like, listen,
so
you
Austin,
can't have a spherical excess.
14.7 and 6 kilometers.
Could you repeat the
got
page?
Yeah, 93, number 7.
93 of the PDF or 93 of the publication?
Of the actual.
How many kilometers with the legs, Austin?
I just answered that.
I didn't hear you answer that. Would you please say it
7
again?
and 14.
So 7 and 14. What was the third one?
6, 7, and 14.
6, 7, and 14. So it's a very tiny triangle. You'd realize that there would be a very small spherical excess of that, right?
Would there be 0 spherical excess?
No.
Oh, what would 180 degrees mean?
What do you mean? What does 180 degrees mean?
What would 180 degrees mean?
All right, so I'm on page
No, it's not.
93.
Don't save him. See if you can answer. What would 180 degrees mean, Bob?
If there was a triangle with 180 degrees?
Yeah.
Internal angles, that would be on a plane.
Okay, thank you. Yeah,
what does a triangle with 180? What does a triangle with 180 degrees 1.23 arc seconds mean?
You mean after we took all kinds of different measurements and had spherical
measurements
assumptions and then took the average?
Raw measurement.
You scared of the answer?
Raw measurements. Answer the question.
Literally in the act of answering, and you say, "Is he scared?"
Yeah, I was like answering. Right. So after we make all kinds of spherical
the
corrections
internal
and
angles of the
assumptions,
triangle
it would
are
be-
180 degrees 1.2.
God, you're so scared. So it would be that we took line of sight, straight line measurements, 2 straight line of sights to angles, horizontals, and then we put that on top of a spherical assumption. A spherical triangle and a spherical excess.
So observed angles.
Okay, so 180 degrees 1.23 seconds is not 180 degrees though, right?
Didn't I just answer that?
Yeah, you tried to put some stuff into it, but that was the measurement of the triangle was 180 degrees, 1.23 arc seconds, according to Brian's computation and using his example. That's not
So
a, that's
do you agree
not
that
a
none of
planar
these can be
triangle, right?
180? You agree none of these can be 180?
That's not 180. It's 180.
I'm saying, if you agree that none of them, can be 180.
Austin,
Listen,
if they're small
I don't think
triangles,
that
that's going to be under the
1.23 arc seconds is within the margin of error. So
What's the
I
margin
don't
of error?
see. I don't see what your point is.
What's the
That's
margin?
what I'm
of error?
saying. That's what I said.
It's
I
less
want
than
to
an
know.
arc second, isn't it?
You don't know.
Yeah,
It's less
isn't
than an
point.
arc second, isn't it?
No, it's not.
What was the margin of error?
You
Mike?
tell me whether or not if it's in the margin of error. That's what I'm asking.
It's not in the margin of error. It's outside of the margin of error.
Okay,
No,
can
what's
I
the
see
margin
a
of error?
can I see a citation for the margin of error? Because I disagree.
Mike already gave you the margins.
It has it on there. It does have a margin of error on there, but only for two aspects of it, not all of it, because I already read where it shows that there are other margins of error. I also pointed out that if you look at the maximum difference between the intersections, that would also give you the margin of error.
Yeah.
Overall margin of
Well,
error.
then you have your work cut out for you, Austin. Go ahead and show it, as Mike
Yeah,
asked.
it's funny. It's funny though that you guys swear up and down this is definitive proof of a globe, and you haven't even done any of the actual testing of whether or not that's true.
I certainly have. Yeah, page 218,
So.
219.
You think so?
You think I'm gonna get bored?
And Austin, you were very, very specific about what if it adds to exactly 180. Then you're happy to say that that's flat Earth. But
no, I
if
wouldn't
it's
say- I
not
wouldn't say that.
180, then you're like, oh, words.
No, I would never say. When I read through all the assumptions baked into this thing, I would never say it proves anything, and I haven't even finished reading it.
But what assumptions are in the observed angles?
I just told you. You actually establish sea level with a correction. You have an initial observer point with spherical assumption coordinate systems, and then you have a weighted equation that is just an approximate formula. So when I look into all that, and you're just claiming that they didn't account for any of it, but the actual paper says they do have to account for all of that.
Observed angles.
Before they actually write down their
Just
recorded
observed
data.
angles.
It seems to me that maybe you just don't know what all they do before they actually record the observed angle.
Hey, and aren't these the guys that say level is curved?
Surveyors are the ones that say
problem
level
you're
is
running
curved.
into with the sea level argument.
Level is curved, right? So if we're-
Surveyors say that, Michael.
Austin, the
Surveyors
problem
say
you
that.
run
Yeah,
into when
yeah.
you-
So if you're correcting for spherical sea level, mean sea level on a spherical datum, what's that imply?
It implies nothing when it comes to azimuth, and that's my question. to Austin.
What it
Sea level-
implies is
Hey,
that.
give me a second, would you? Do you
Hey,
mind?
yes, I
Do
do.
you
Don't
mind?
yell. Don't yell at me, bub. You're not
All
at
right,
home.
then don't talk over me. Austin,
No, it's
when you're
don't yell
dealing
at me.
with sea level, that has to do with elevation measurements. And
Don't talk to me like that. I
Ooh.
don't put up.
Right in the
Everybody
middle there.
needs
You
to know
just
that.
just butte the guy right in the
Yeah.
middle there. What's
no,
up with
he
that,
tossed
Michael?
me out is what he did, but I came right
No,
back in.
No, I tossed him in because get the point. Don't talk to me like that. I do not talk to you like that, and you're not at home.
Oh, you
neither
absolutely
am I.
are. You 100% are.
I'm not. I'm not yelling at
You're
anybody like a
completely
child.
talking over him. You're ignoring what he says in the middle of his statement, and you're being rude by just booting him out in the middle
Yeah,
of his statement.
that's not
Yeah,
what I'm
that's
addressing.
a problem there, Michael.
That's not what I'm addressing. He's talking to me like I'm a child, screaming and yelling. There's lag on the internet. Get over it.
He is a child.
Right, did
Act
you have
act like a man.
Did you have a question, Bob?
I have a question. I have a statement too.
Great.
When you're dealing with this mean sea level issue, Austin, that has to do with zeniths and looking at elevation. It has absolutely nothing to do with an azimuth from a point. You don't need to know the coordinate to say that that point is 30 degrees from this point. All right, that your argument is erroneous.
Oh, okay. So you actually have to do many things. I explained that you have to have your weighted equation, that you actually just have an approximate formula due to heavy computation. Then you also have to transform sea level into this geodetic assumption. Then you actually have to use spherical coordinate systems. And if we find out, which we'll just look and we'll find out because you haven't looked yet, none of you have, you just repeat McToon.
He won't do the
If
math.
we look and find out that what they do is they look at the observed angle, but they actually have to account for certain spherical assumptions before they record the actual data. Well, then you guys have a problem, and you'll just pretend this never happened.
Well, actually, that's your error in reasoning because, as Mike said many, many times, you have the raw data and you have the corrected data. Throw the corrected data out. Just go with the raw data. Do your own corrections on it. Show me where they put the azimuth how they adjusted the azimuth to make the Earth look like a sphere. That's all you have to do.
Well, I just read off a few of them that show very clearly that you have like no spherical.
It's got to be repeated.
And you sat down and said that has to do with the corrections that were made. Throw the corrections out. Do your own. Not a problem, man.
I'm pretty bored at this point. You just seem to not be listening.
It's like,
Well,
like
that's
turn
because
up
you're not understanding what I'm saying. That's the big deal.
It's going to make your point true.
Austin's like, I'm bored. He does that when he has no answer. It's his,
that
it's
has
his
to be
defense.
a name for that fallacy because it happens so frequently. Like
Gregory guy.
what has been the questions have been directly answered. I've been
No,
following
he's
this
never
entire
answered
time.
it.
You can clearly hear me in the middle.
It'll take time.
You can clearly hear me in the middle talking. So the questions have been directly answered. The point of contention has been repeated over and over again. Austin just read it. We heard it earlier. And what I've heard in response to this frequently, so many times, is just turn the dial of condescension and smug petulance up as though that's going to make your whistling past what he said, what Austin read, true and valid.
The condescension
Austin is raising an objection to the assumptions that were made in the corrections. Fine.
Well, it specifically says that
Throw
even with
those
the actual
corrections
angle,
out.
it says you have an
Throw the
adjusted
corrections
angle
out.
before you
Use
record it.
Use the raw data.
No, it says you have an adjusted angle. You have a formula for an adjusted angle before you record it.
No.
Yes.
It said the raw angle is the raw angle. The adjusted angle is the adjusted angle, the one that has the
where's the
plot.
distinction in the chart?
The first one says raw data, and the second one says
first says
corrected.
observed angles. Yep.
Okay, and it says so you can see the adjusted angle is not the same as the corrections. The corrections, as MC Toon just enlightened us, was actually looking at the average of all the intersections. That's not the adjusted.
No. The observed angle is the raw data, and then the corrections are applied. That's what MC was talking about.
So they adjust the angle with the corrections?
In the corrected angle, not in the observed angle. That's what you're failing to grasp.
Well, you say that, but when I read right here, it's saying that you have to make assumptive formula calculations beforehand.
For what? For what
Before
specific
you have the
measurement are they
corrected
talking
angle,
about?
yes.
Well, how many times do I have to read? Let me go find it for the 15th.
All right, here. Let me give you an analogy, Austin, to help you out. All right. There's a thing on a compass called magnetic declination. When I look at my compass, it says I'm looking north. I apply the correction for magnetic declination and come up with my true reading of 354 degrees because my magnetic declination is 6 degrees. The raw data is the 360 degree due north that I read off the compass. The corrected data, or the corrected true north, is based on the corrections that I have to apply. Now you can take the 360 degrees and put your own corrections into it. Whatever you need to, whatever you can justify. All you have to do is just do that.
Like I said, man, I'm not an expert in this, so maybe you'll be able to answer the question I asked, the first question I asked. It says to derive the probable error of an adjusted angle by the rigorous method involves so much heavy computation in solving the various weight equations that one is forced to use some approximate formula for computing it. Although observations upon different signals have been given equal weight in the adjustment, it is nevertheless recognized that a difference of accuracy exists and that it is desirable and it should be taken into account in computing the probable errors. This may be accomplished to a certain extent by making the computed probable error for each direction depend upon the residuals from that direction only, instead of basing it upon the whole group of residuals. What does that mean?
That means that you take the azimuth angle, and that's your observed angle. And then you apply those assumptions, those computations and everything out, and then come up with a corrected angle. Is that not right, MC?
Yeah, that's yeah.
So that's exactly what they're saying.
So
I can't explain it to you any more clear than that.
Wait up. He said all they were doing was looking at the different intersections and then taking the average, and then that just happens to always be more than 180. But then I read right here, it says that to derive the probable error of an adjusted angle by the rigorous method involves so much heavy computation in solving the various weight equations that one is forced to use some approximate formula for computing it. Now, that has nothing to do with averaging out the intersections. It says specifically
it's
something
for the
different.
adjustments, Austin, not the raw.
All right. Austin, when you want to take an azimuth angle, Do you not agree with the idea that if you want to take an azimuth angle, you don't just shoot it once and call it good. You shoot it 10 times.
Sequitur.
All right. And then you take those 10
Red
readings and you average them. That is your observed angle, your
Red
azimuth
herring
angle. All right. Well, you can use fallacy all you want. I don't really care.
I was reading
But,
it again. So it says the probable error of an adjusted angle.
well,
by the
just read
rigorous
it again.
method
Oh my
involves
gosh,
so much-
Austin, that's enough. That's enough, Austin.
So just say you don't know.
You're talking
No,
about the
no.
adjusted angle, not about the observed angle. If you think that the adjustments were done wrong, and a massive computation somehow the radius showed up in them, then awesome. Do
All
the
right, let me
computations
respond
the
about what
hard way
Austin
now that
actually
we have the
read. Can I-
CPU time.
Can I please respond? No, what I think was wrong was your claim about the adjusted angle and how it's nothing more than taking the average of the intersection, because the paper specifically says that isn't the case, and that to derive the error of the adjusted angle, there's a rigorous method that involves so much heavy computation.
I know, we heard it.
Yeah, we
that
got
one
it.
is forced to
Yeah.
use some
And that is also
approximate
not what we said,
formula.
Austin,
That has
you know
nothing to do with taking an average.
Austin, And you think that somehow that computation is where they're hiding the radius of the Earth? Just show it.
Do you know what the
Go
computation
ahead.
is?
No,
we
but
point-
apparently
it's not-
you're going to look into it and find that they inserted the radius there somehow.
Would you like to admit that you were wrong about
You
how they
didn't
did the
say
adjusted
that,
angle?
which demonstrates you don't
Listen.
believe what they're saying about their own work. This is dishonest.
It's not
Oh,
hidden.
Gregory,
We've
you're
already
cute.
pointed out with the meridian, longitude, and latitude.
You know, how many
Astronomical
times does this have to be
observations and
explained?
latitude and longitude.
All right, well,
corrections.
this is getting old,
Talk about
Austin.
Dunning-Kruger, dude.
I don't know. For two guys
Time
that
for
get
you
so
to be
mad
done.
about interruption, you do it an awful lot. You
All right,
fucking hypocrite.
that's good. Thanks a lot. All right,
Yeah.
Michael,
You
I
admit you were wrong
will
about
gladly
I'll
address
over
this
my knee
again.
and spank your ass like a
Yeah,
child.
sure, sure. All right,
Let's
all
end
right.
on a good note,
I'm gonna head
man.
out.
Like,
Hey, Shane,
end on a good
thanks a
Act like
lot.
one.
Shane, thanks a lot.
Yeah,
This
it
has
was fun.
been a lot of fun.
Kind of got away from me, but that's all right.
And yeah, I get it.
I'm
It
still
happens.
smiling.
So, but Michael,
Will you
I
admit you were
hope
wrong
to,
about
that we could
just-
talk. No, shut up,
please.
Austin. Austin, if
Come
you
on,
want to, if
man.
you want to do the math, show me the math.
Man.
Everybody else, I'm gonna stick around on my channel and talk to you guys in a little bit. So
You're gonna go tell me you weren't
Tartaria
wrong
server,
about the
thanks a
adjust-
lot. Oh my gosh, Austin just can't shut up. Oh, and it's desperation, right? It is like they always do. And let me get it here. There it is. It's the anti-scientific method, because of course Austin, even though he says that he wants to be a truther, he's not. We know he's not, because if he was a truther, then when he found data and things that contradicted his pre-selected conclusion, he would accept them. And so the fact that these surveys show, let me show you. I'm going to pull up the right. They wanted to focus on these small ones here. I'll show you this. These little ones here. Oh, that's not the little one. These little ones here with the 1 arc second, right? And he completely ignores these here, where there's 62 arc seconds of if there's 62 arc seconds, there's no amount of corrections that can fix it. And Michael J. Smith, the other guy, he is some sort of he uses a theodolite for his employment. Apparently, and is a flat earther, so he's not a geodetic surveyor of any sort. Yeah, Bob was great. Bob was great. Thanks, Bob. Other Bob. So anyway, so we've got this 62.16 observed angle. And so the challenge for them, see, that they are asserting that somehow this 62.16 spherical excess somehow has been faked or baked in, or the process they used output that, even though, you know, they did these measurements, and that's they're gonna have a hard time finding that. So whatever Michael J. Smith was showing, and for reference, Michael J. Smith is an insult. He's besmirching, that's not his actual name. He's besmirching somebody's death. Look it up. So I won't say that name anymore. Maybe I'll refrain from saying his whole name. Anyway, so if you look at the 62.160 and then after the adjustment 62.66, not much difference, right? This is about having a precise measurement at the end of the measurement. This isn't somehow faking. See, if they had to fake the radius of the Earth into every one of these measurements, because that's what they would have to do in order to get a spherical excess that's directly proportional to the area of the triangle, right? They'd have to put it in there somehow. And so here is right here, the same one. I put it in my spreadsheet, Iba-Pa, Pilot Peak, Ogden Peak, right? And Iba-Pa, Pilot Peak, Ogden Peak. I put all these numbers in. I typed them all in. This took quite a while to type them all in. But this is my spreadsheet here. Page 218. This is triangle number 28. I put hours, minutes, seconds. This is then I converted it to degrees because I much prefer working in degrees. But anyway, so this column here, these three columns sum up to 62.16. So I did all the work here to sum these, I think. Oh no, I didn't. I took this number. I thought this was pretty good. I converted all of these degree, minute, seconds to degrees here, decimal degrees, these three here. Then I sum them, 180.17. And then I take 180 minus that times 3,600. So you see here, H267, that's this cell right here, minus 180, and then multiply by 3,600. That's arc seconds. And so that gives me this. So this was my check to make sure that I typed in the numbers correctly to the book, because the book has 62.16, 62.160 there. And I did the math to go around and come back to it, and I got the same number. And so that's my confirmation that I typed these in correctly. I added a couple different things in here because when you type in a lot of numbers, you can make some mistakes. And so I wanted to make sure I got them all correct. Then this is the adjustment that they made. So negative 0.07. Go here, see negative 0.07 is at the top there. You can't see my cursor, unfortunately, but it's the correction there on the Iba-Pa. So it's the you see that? I hope you see it. Anyway, so then I keep going here. This is the corrected amounts. These are the new corrected amounts with the new spherical excess after adjustment. So 62.22, and we look at the numbers here again. This is 62.66. Oh, what number? I was looking at the wrong number. There it is, 62.66. So that's another check. So this particular 62.66, I did not type in from the book. I did the math and it output that, and then I verify that it matches the book. Now here we go a little more. This is the log of the distance, and this is the distance, right? So 185,460 is the distance. That's the log base 10 of the distance. I don't need it. I typed it in by hand. Did I do that? I think I typed those in. Anyway. And then this here, this is the important thing. So I'll show you this particular formula here. This one here. I'll make it a little bigger for you. This particular formula is a relationship in spherical trigonometry between the sides of a spherical triangle and the angles of a spherical triangle and the radius. So you can see this lowercase c and the uppercase c, one is a side and one is an angle, and the r is the radius. And you see there's just one radius, one r in here, and all of the rest of them are angles and sides. So what I did is I contacted professor, or Dr. Clive Wells, and I asked him, can you show the proof of this formula? And so he did that. He actually went through the whole thing. So it's on the website, mctoon.net/SE. But I solved for R. I used that. I used actually Wolfram Alpha to solve for R. And here it is. This is the radius. So given three sides, actually given one side, C, lowercase c is one side, and three angles, A, B, and C, then you can solve for the radius. And that's what I did. So I put this into the spreadsheet. And that's what this is doing here, the 6,400 kilometer, or 6,400,000 meters. It actually is running that particular formula, and it's not showing up here. I'm in view only mode, so it's not. I don't know why it's not. Oh, there it is. Now it's updating. So you see there arc, cosine, cosecant, radians. I'm converting all these. So that's applying that formula. So that gives and the formula only uses one of the sides. So I apply that formula 3 times. That's what this column actually is. This other column is applying the formula on the observed angles. So this is on the modified angles. So it doesn't matter. This is the beauty. This one particular triangle outputs 6,400 kilometers for the radius 3 times. The observed angles, the non-corrected angles. The corrected angles outputs that. And this is a running sum. So I'm averaging everything above that. So that's what this is. So I typed in triangles and triangles and triangles, and I typed in a lot of them, and you can see here's my empty ones that I haven't typed in yet. But this gives the overall, just based on the spherical excess and the sides of the triangles, it gives a radius of the Earth that's consistent across all of them. So if somehow this is being faked, the math will show it, because they have to input the radius of the Earth, right? So their presumption is, they presume that the Earth is flat. Then they are presuming that somehow the math is forcing things into it. If it's forcing things into it, they must be forcing the radius into it, because they all output the radius. All of them output the radius. So, and it's a consistent radius. It's not a widely varying radius. You see here, 6,374, 6,374, 6,374. Remember, this is at 39 degrees north latitude. Homework for you. Figure that one out. All right. I did a lot of work on this. And when I did this, let me show you. This is important, because they found a couple outliers, and a conspiracy theorist sees the outlier as like, that's the truth. It's confirmation bias, right? When you're actually doing things and doing statistical things and stuff like that, you see an outlier, you're like, that's probably an error or some lower quality measurement or something like that. So yeah, when you're looking at these triangles where the sides are 8 kilometers, 13 kilometers, and 11 kilometers instead of hundreds of kilometers, well, then a smaller variation at a 10th or a 100th of an arc second actually has a big variation in the output. So yes, I did see, and so here's one of them right here. I specifically knew about it, and I knew that someday they might actually look at the data. Someday they might actually look at the data. So it's all right here. I've had this spreadsheet on my website for years with these 3 specific numbers put in. I knew they were there, and I knew that the corrected versions didn't have it, because they did the corrections. They knew what they were doing better than Top Left Austin does. So you want to link mctoon.net/SE. So could a mod just drop that in there, please? Yeah, this isn't /R, this is /SE. So anyway, yes, And I'll tell you, yes, I've had that sitting there waiting for them. That's not the only thing I have sitting waiting. I'm not going to tell you. I don't know off the top of my head. But I have things for when somebody brings it up, sitting in my Evernote and in my Dropbox folders, ready for them. So some of them they probably never will bring up, but I have them because there are some misunderstandings of the globe that they get really often. They often misunderstand how to observe things across the water, right? They love that. But there's less common things that they misunderstand. So if one of them shows up with one of the things I've already prepared, well, already prepared it. And so today you saw one of them. Now, thanks to Andrew Johnston, who was on Flatzoid. And Andrew Johnston explained this way better than I could have. Right? I knew about it. I had it. But he did a great job. And so Andrew Johnston, please contact me. I'd like to bring you on and just talk about this because you were fantastic on Flatzoid. And you referenced my document. You talked about this. And so thank you for that. I appreciate the reference. And it was great. I watched it. I actually watched it today. And yes, great job. Great job, Andrew. So he's Australian. Maybe he's awake now. Anyway, send me an email or a DM and I will have a look at it. So anyway, I've got some super chats here to read. So let me get to that. Yeah, I couldn't incorporate them. Austin, Austin monopolizes everything. His gigantic narcissist ego can't let him not do it. And of course, Michael, I'll just say Michael. Michael, this was his, he kind of has a little background in surveying, so he wanted to talk about it. Wouldn't stop. So anyway, let me read this. We've got Nurikul. Nurikul is a new member at Einstein. Thank you for that, Nurikul. We've got Stringfellow Hawk for $5 says Whitsitt could be dead for 5 years and he'd still be talking. I did incorporate that already. Lael says the problem is that we have no way to know the length contraction of his word salad. If only we could apply length contraction to his word salad. Mr. Toffel says, get your face palm protection ready, people. Yes, that must have been when Whitsitt was dropping in. Dr. Nimrod says, I love being blue for you, even if I'm on the loo. I understand people consume content while on the loo. We just don't want to know about it. Thank you for that, Dr. Nimrod. Gary Little for $5 says, NASA #1 globe debunk, but VHS UHF radio propagation, as we have used it since 1950, debunks any flat earth proof. It does. And I should, what kind of thing could be done that could be shown that is more than just a, kind of a claim, right? That would be the thing to do. And of course, yeah, there's plenty. I just work on that. Gary, somebody else, if you want to help me build a web page on some of the information on radio propagation like that, I'd love it. I know that so in their ignorance, Whitsitt, in his blazing ignorance, thinks that Marconi's communication across the Atlantic at less than 30 megahertz is somehow shows that the Earth is flat. But why? What Whitsitt? Why doesn't it work above 30 megahertz? Is it right? It doesn't. The reason why is that Marconi back in the late 1800s built a very powerful antenna and they picked it up across the Atlantic Ocean, and that's because less than 30 megahertz it refracts and it bounces and it reflects then actually off of the ionosphere, and so less than 30 megahertz you can get much longer communications because of that. But once you go over 30 megahertz, it stops reflecting off of the ionosphere. Whitsitt has no answer. Flat earthers have no answer for that. I don't know what they will make up on the fly. I love listening to their on the fly nonsense, but I have heard Witsit talk about that in particular. So Triple Crow K says flerfs sound even dumber when trying to sound smart. Yeah, they do. Industrial Lord says Austin is a joke. CC for top left. CC. No, hold on. Flatzoid. There's so many to choose from. How can we be forced to pick? Shovelhead Steve says, been a member for 4 months, says Witless picks worms out of pig dookie. Gross. Oh, I used to live in a less urban area, and I know people that were pig farmers, and they had a lagoon. Ooh, the lagoon is where the liquid poo is, and for pigs, it's liquid. It's not like horse or who is it that has who has the cubical ones? Are they Tasmanian? Wombats. Is it wombats? I think it's wombats. Anyway, no, it's a slurry in that lagoon. And so, yeah, so if a pigger farmer ever asks you if you want to go swimming in his lagoon, you do not. And so I don't know how worms live in that, but all right. Industrial Nerd gifted a membership. Thank you for that, Industrial Nerd. I don't know who picked it up. PhD Tony always comes in with this. I love it. He says, we can demonstrate the shape of the Earth using propagation patterns of seismic and atmospheric pressure waves, the universal accuracy of spherical distance formula, and reciprocal zenith angles. I actually heard them talking about reciprocal zenith angles. What did they say? I think they're kind of their fallback is you're presuming that the Earth is a globe. But when you just look at the raw numbers, there's no presumption allowed. That's why I say with the observed angles on the spherical excess there, the observed angles, there's no presumption allowed, right? Even if they're using coordinate systems, a spherical coordinate system, they're just looking at angles between points. The coordinate system doesn't change that there is a specific angle between those points and those points and those points, and they sum to more than 180. You don't need the length of the sides, right? If you want to get the radius, you do, but you don't need the lengths of the sides to be accurate. You don't need to even know where those points are. It makes no difference where the points are. You could pick random points, and as long as your precision of your instrument is high enough, if you measure spherical excess, that confirms a globe and it falsifies flat Earth. It's all you need. So all of this stuff that Michael was talking about, where somehow he thinks that the latitude longitude makes a difference. Latitude and longitude doesn't even include the radius, yet the radius was output. It doesn't matter. Observed angles, raw numbers, that's it. They go off into other stuff because that thing ruins them. The other stuff is where they focus their time to distract from the thing that ruins them. They have to. Yes. Well, thank you for that, PhD Tony. Dave D says McToons roared at Witsit, which, like Omega that he is, immediately rolled over and quit celebrating in his own ignorance. He did shut up after that. But I'm like, I'm not scared of it. You interrupted me, douchebag. Yeah, Witsit, douchebag. The Sun Express says Austin Nipsit's entire modus operandi: read paragraph, misinterpret, misrepresent, and repeat. Yes. How does all of the things that he kept reading change that the observed angles sum to more than 360 or more than 180 degrees? It doesn't. None of what he said changes that the observed angles sum to more than 180 degrees. Stringer News 1 says, you're spiraling, bro. Austin loves that And of course Michael's like, he was kind of like a, Brian Leak wasn't there, so like Michael had to be the little dog, like yipping and following, like, oh, I'm gonna repeat what he said. Do. That was good. Spiraling. Space Tomato. Hey, is that you, Zumi? Says Austin is one of the most toxic flat earthers out there, so being toxic toward him is a compliment and is therefore downright wholesome. Yes. RT96, Austin, how tall are you? You may not presume you have height when you make your measurement. That's, oh yeah, absolutely it. That reminds me. So this book here, I finished it. It took me a long time to read it. I read it over. I'd go back and read stuff. So from Christine Garwood, there's her bio thing. I found her on Facebook and we had a little chat. I asked if she'd come on to talk about this. She wrote this in the 90s. She's like, it's been too long. So she declined my invitation. So what I'm going to do is I'm going to do a book review of this sometime. It's great. It's really good. So wait for the book review. But she actually goes into Zeticism quite a bit. They don't talk about it as much. But Samuel Robotham did. Zeticism is, let's reject everything that I didn't do myself. And why do they do that? Because everything that you didn't do yourself contradicts you. Right? This is it right here. You see, how can you reject contradicting evidence? If you being honest, you can't. So with Zeticism, they pretend to be honest by pre-rejecting everything. And then they're only going to do things that they've done themselves. The problem is that they don't just accept things. They only accept things that agree with them that somebody else did. And you see that in the flat earthers. If a flat earther talks about the black swan and they're like, well, you have to do it yourself. Well, of course they didn't do it themselves. Only Beelzebub, whatever his name is. He's the only one that did it himself. So, all right, well, that doesn't work. So they'll selectively accept that. And then they'll look, well, it's this far out. Well, hold on a second. How did you, rejecting everything else that you didn't do, measure the distance out from the shoreline to the oil platform? How did you do that? Oh, you used Google Earth or Google Maps. Well, Google Maps uses the Haversine formula or the Vicente formula to get the distances. So you can't get the distance without presuming the Earth to be a globe of a specific radius. Kind of a first law of flerf there, right? It contradicted you coming into it. It's this fallacy of stolen concept. You can't use a distance measurement based on the globe for flat Earth. It doesn't work that way. So anyway, Serena News 1 says Austin can't be bad at math. He does no math. That's right. I've never seen him do math. He has talked about, this is funny. He said people, when he was in school, thought that he was cheating because he did so good on the math. No, I don't, I'm not going to say that he was untrue in that, but he was in high school, right? He claims that he got a full ride to college. A full ride to a non-NCAA school that's like Division 2 or 3 within their, I forget the name of their division. I looked up the rules. They don't get a whole lot of scholarships. So in order to give a full ride to somebody would have to be a huge, huge thing. Typically, they don't do that. And then he was redshirted. That means he didn't play that first year. And then he dropped out of school. I don't know. If I got a full ride, I wouldn't just drop out of school. If I had the aptitude to do the math. So, PJC. All right, we'll see you later. So yeah, I don't believe that Austin is good at math. But like I said, he could prove me wrong. Ableist says, everyone check out Venus and Jupiter in your evening sky. They are this far apart. Beautiful sight. Yeah, I got a few pictures and video of Venus and Jupiter while on vacation. And I'm just getting into it. So I'll show at some point. The P1000 focus at extreme zoom is tough. But if you just flip that switch to manual focus, you can actually just put it right to infinity, or you back it off a little bit. And you can get Jupiter sort of into focus and definitely see the moons. So when flat earthers are like, they show this blobby thing, all you need to do is flip the switch to manual focus and twist the ring. They are incapable of even doing that. It's embarrassing. Green Bull says, for the love of all things holy, can you please never talk to Austin again? He's a top left Hall of Famer who couldn't find Lake Titicaca on a map. That's the problem with the Tartaria server, right? If I'm there, he's going to come in. That's what he does. He follows me. Austin, why do you follow me? Justin Messenger says, it is disappointing that such a simple point was not understood. Observed versus corrected. Shake my head. Good job, Tune. Yeah. It's baffling that the straw grasping was apparent. The observed, like I said, there's this whole network of triangles. And when they do one measurement all the way around, here we go. I'll use Industrial Nerds thing. They point the theodolite. This theodolite, they typically only measure azimuth angles. They don't measure angles this way. They use a different theodolite to measure the zenith angles. A totally different instrument. So when they're like talking about elevations and zenith angles and all this, like, it can't even measure it. That device is incapable. Anyway, so start here, right? Measure an angle between here and here, right? Measure it many, many times. And then measure this angle from here to here, right? So the 0.1, 0.2 to 0.3. I'll be at 0.3, right? Measure this. And then from 0.3 to 0.4, right? Measure that. And then from 0.4 back to 0.1, right? All of that must sum to 360 degrees. That's their checksum. If it sums to more than 360 degrees, they know that there's something wrong. Maybe it's a gross error and they need to redo measurements. Maybe it's a modification that they need to make because there was a small error, and they're going to look at the network of other things and say, oh yeah, this one here, we came up with too much, but over there, we came up with too few. Okay, so that checksums out, and we see that that's where it was. So they'll make those adjustments. And that's what those adjustments actually are. None of them violate the numbers. I showed the sums there on page 4 of that spreadsheet on mc2net/se. Sheet 4 of that spreadsheet, I actually typed in all the numbers, and they sum up to 0. So it's not like they're saying, oh, well, here's a triangle, and in reality, it measured exactly 180 degrees, but we're going to add some. Right? If they added some, then every single triangle would add some, and that means that the sums of those 360 degrees would be all more than 360 degrees. Right? And that's so when Austin's like, I'm going to find the math. Like, no, you're not. When you do it, you're going to find that they knew what they were doing, and they were checksumming what they did every step of the way. And back to what Andrew Johnston said, he talked about how they measured the specific, he did this, the length of one of the first triangles, what they typically do. And then somewhere along the way, it's like 400 kilometers away, they did that again. They measured another triangle side manually. And when they got there, they have two things. They have the predicted length of that and the measured length of that. All of this absolutely hinges on them knowing the shape of the earth. If they don't know the shape of the earth, they're going to get it wrong. It's going to be dramatically wrong in proportion to how far off the shape of the earth is to what they think the shape of the earth is. So if they got it wrong, it would be dramatic. It was less than a centimeter. 400 kilometers away from the first measured triangle to the second measured triangle. All of the triangles in between were measured with these azimuths, right? All of the lengths of them were measured using that. So if the lengths of those triangles were wrong, that would show up as an error when they got to this other measured triangle or side. It didn't. It was less than a centimeter. Amazing accuracy. Absolutely amazing. That publication is, they're so good. And maybe that's how all the surveys were done and they just didn't write it out. This one they wrote out, and I know that's the case. I've spoken with some surveyors. A lot of the time they do a survey and all of the work that they did, they didn't include the publication, right? You'd hire a private firm to do some survey work and they do the work and then they give it to you. They don't give you the math. Well, this was done by the NOAA, I think. Anyway, a public agency. So all of the work was public. So, and included in it. So, all right. Judy, you got this. Gary Wybenga, I'm going to suggest to MC Toon that we just time you out until you be a man and schedule your talk with Professor Phil Bell. Hey, Gary, will you schedule? I hope you're listening. Because if you're not listening, if you're in a live stream and not listening, right, read the room. Gary, I hope you're listening. Will you schedule? You said you needed some time to do some prep work. It's been a month, I think, or more. Will we now schedule that with Professor Phil Bell? Gary? I hope so. I'd love to see it. Frocat says, Lael says, it's funny that those flerfs you want to accept their surveyor's testimony and they don't accept the surveyor's testimony that say that the earth is a sphere. That's right. So yeah, they're like, well, do you believe that they said that going into it that they knew the earth was a globe. Of course. There's no question that the earth is a globe. They're surveyors. They know the shape of the earth. Their purpose was to measure as one of the things, was to output the radius of the globe. So yeah, they didn't go into this to prove that the earth was a globe or to check whether the earth was a globe. They knew it going in. But all of the techniques that they did, those other ones, other than just these raw as observed angles and the corrections, all of the things that they did, if they did not know the shape of the earth to be a sphere, if it was a different shape than they presumed going into it, then there would be drastic errors in all of their measurements and calculations. But there weren't. So, all right. Real Cygnus, do you know if that Chong dude is an actual engineer like Mullins? I don't know anything about that Chong dude. I saw somebody saying that Chong claimed to be a civil engineer. So a civil engineer sometimes deals with surveying work, but typically not a lot, right? A civil engineer isn't a geodetic surveyor. Geodetic surveyor is a different degree, different program, different certification. But the civil engineer deals with that in a bit, right? So they need to do small scale surveys. So they overlap with being a planar surveyor. And I suppose somebody that's got a civil engineering degree would pretty easily be able to get a planar surveying certification. But I don't know. There are a handful of planar surveyors that are flerfs. Like that Michael guy claims to be a planar surveyor. The thing is that they never go and take their theodolites and do the kinds of things that they could do to confirm whether or not the earth is a sphere, like do reciprocal zenith angles. They never have done that. I've never seen a flerf go do that and say, oh, look, they add up to flat earth supporting it. They don't. They don't go and do like what Jesse Kozlowski did across a smooth lake and from one side to the other and see if there's a drop. Jesse Kozlowski did that twice. There's a drop. And there's in the 70s, there's a big survey that did a whole bunch of reciprocal zenith angles. I think I have it on my website. You might find it. Wait, find it there. I think MC2. Let me look. Let me look here. Was it curve? Or is it, no, it's yeah, so mc2.net/curve. I have a whole bunch of measurements of the curve. They never want to look at the measurements, and if they do, they just hand wave reject it. But no, I think it's burden. I prepared this page/burden for debating Whitsitt and Thompson, Nathan Thompson, because at the time Austin was like to say, well, if you make a claim, you have the burden. I'm like, oh, well, here it is. MC2 says burden. Go ahead. I have met the burden. So for you to say, nuh-uh, you need to go through all of these things and find the errors or the misinterpretations or the lies or the flaws in all of these things here. Put it up there for it. Yeah, so you can all see it. So let's see. Maybe it is. Maybe it is on this page, the /curve that I have. Oh yeah, here it is. Okay, so okay, if the Earth is a sphere, vertical lines must diverge. And so this is the main surveyor. He is a licensed geodetic surveyor, to my knowledge, though people have asserted that he's not. In ignorance, they have asserted that he's not. Or as I know, nobody's actually shown anything other than claims. And I think that mostly comes from Bev. So you see, Bev thinks that the Earth is flat. He's a flerf. And he thinks that anybody that is a surveyor that doesn't agree with him can't be a surveyor. That's how weird he is. Anyway, so he has these videos here where he actually measured vertical zenith angles. So I don't have the one that from the 70s. But anyway, you can find that one probably pretty easily. Anyway, Jesse did these two across the lake there, and here he did the one across. Oh yeah, this is I think this is, yeah, this is across a highway here at 2 mile markers. And you see the target there, where the crosshair is above that target. If I remember that correctly, both spots were the same elevation. So he did what flerfs don't do. He recorded data. Some do. Doesn't work for him when they do. And yeah, so here's the zenith angles. He's at 10 arc seconds. You see that? 13 arc seconds, 12 arc seconds, 5 arc seconds, 18. So he's using an instrument. I think he's using the theodolite is using is accurate to 1 arc second. So, there it is. Instrument height 5.53 above the ground. Target height 5.42 off the ground. And then the other direction, he did the same thing. Instrument height 5.42, right? Target height 5.54. And then he did the math here. Finds that it's 1 minute, 11 arc seconds of divergence. Amazing. When you actually do the work, you find that it does it confirms a globe, but they don't want that. So Brocat says you should probably start a monthly top left award. Then select the annual top left from the 12 monthly winners. Titicaca. That'd be great. That'd be great. Every month. That'd be so much work. And then yes. It's a shootout of the 12. That's too many. It's actually, we had 30 last year. It's way too many. And so we're going to 5 or 6 this year. I think that's going to be a good number. So, Space Tomato says they're growing tomatoes in space. Thank you for that, Space Tomato. We know it's you, Zoomy. It's okay. I won't say anything. Fa of the QTube family for $5 says that day that Whitsitt does the math to back up his assertions will be the same day that the devil needs a snowblower. Truer things have never been said. At least that is my position. And Austin, go ahead. Show that I'm wrong. Fred Farkle is a new member at Einstein. Thank you very much, Fred Farkle. That's the end of the super chat. So is there anything else? I mean, so this particular, I knew they were doing this. So let me tell you, I knew they were doing this today because Brian Leak did a video, and Bob the Science Guy actually used that video in his nomination where he summed the numbers wrong. But Brian Leakey, who's like Witsit's lapdog, Brian Leakey saw those three triangles where the uncorrected values sum to less than 180, and thought that was a thing, right? Without looking at the corrected angles, and so then apparently Witsit found out about it today. Seriously, here's the problem: when flerfs send me evidence, I look at it. It's usually nothing, right? Almost all of them are, oh, we did a laser across water and ignored refraction. Whoop-de-doo. But I look at it, and over 2 years, I think it's over 2 years ago, it was when I debated Witsit and Thompson on Modern Day Debate. That was when I sent, that's when I made that /burden. It was when I debated him on Modern Day Debate with somebody else that James set me up with, and it was Witsit and Kai. At that one, I sent it to Austin during that debate, and I'd like a DM or whatever. The spherical excess, that page, and the transcontinental triangulation of the American arc of the variola. I sent that to him at the time. It's at least 2 years. I think maybe it's this spring. It's 2 years. It's probably not yet 2 years. Let me correct that. Anyway, he hadn't looked at it until today. Witsit is scared of looking at evidence. He won't look at evidence. And when he does, he misunderstands it. That's his skill. Everybody has a skill. Witsit's skill is misunderstanding things and thinking that he understands them. That is the Dunning-Kruger in him. So you can always count on that, can't you? All right, let me look. This is the one that Witsit actually highlighted, I think, or maybe this is the one that Brian Leak highlighted. You can see this 180, and so Brian Leak thought that this was a problem, that it was 1.29 arc seconds. I don't know why he thought that was a problem. He did mention that it was, he mentioned margin of error, but he never actually looked at the margin of error. And so he's right. I'll give him this. The margin of error is actually, this is within the margin of error for specifically for the spherical triangles. Remember, they're not looking at spherical triangles as proving what they're doing, right? That's not their purpose. They're just looking at the angles and looking at the margins of error. And the really important thing is you still have to sum to 360. It doesn't change anything. You still have to sum to 360. And so when they do the corrections, you can't cheat the numbers. The checksum is still there. So Gary Wybenga says several of your mods are making disgusting comments and insinuations you need to address. Oh no, Gary. All right, let me look here. Repo Sandman is making things. To you. Gary, I emailed MC2, and if he doesn't take care of it, we'll find a way. You crossed the line, PhD Tony. All right, PhD Tony, you may have just earned more respect from me. How is it possible? PhD Tony says, Gary Wybenga, aw, I thought YouTube was going to smite us. Gary, you're kind of a whiner, and you're definitely a liar. So, I mean, when you've been on here, you've lied. Just lied. I mean, you lie when you make claims about how light works. You have no clue. You're just making stuff up, and you know that you're just making stuff up, which makes it a lie. So, all right, I'm looking for where PhD Tony crossed the line. Let's see here. He's Gary. Seriously, you're telling Daddy? What category did you lodge your report under? PhD, you might be surprised. I don't know. I can't find anything that I'm having a problem with. Scrolled off the screen. Oh, whatever. But I see that he called you delusional, Gary. You definitely are delusional. No question about that. Anyway, so Gary, I don't know. Send me the screenshots. I will try to care. Try to not lie, Gary. How about that? Like, seriously, Gary, you're just, it's so sad that a grown adult is just so wrong about everything, just making up just nonsense about stuff. Just stupid. Anyway, Stringer News 1 says, nobody expects the ends of the super chats. And Gary Little says, I'd change my name, but I've had it for 3/4 of a century. I get that, Gary Little. At least it's not, something similar to Wybanga. Imagine having your first and last name is the same. I mean, there's probably another Eric Dubé out there somewhere. Poor guy. So, Stringers one, MC Toon is a Christian and he tolerates your disgusting comments, Gary. Yeah. BT Tony, I'm not going to read it. Says, I confess, I said he should go do what Santos did to the cow he fantasizes about. Oh, yeah. All right. So Gary, it was a low blow. You've never done that in a chat? I don't know. I'll tell you what, Gary, stop lying and I'll care more. Right? All this field of view compression garbage about angles and all, none of that actually is true. It's just lies. Ooh, did you say a bunch of anti-trans things to Brenda tonight, Gary? Because Gary, if I know a lot of you didn't probably watch Saturday's Modern Day Debate where Whitsitt was on, Whitsitt and Nathan something were on, and they're talking to Snake and CP, and Amy was the moderator, and people in the chat were misgendering them and were throwing around some insults to both Snake, I think Snake and definitely Snake and Amy. And I didn't watch it back, but somebody had mentioned that Austin had been misgendering people later, and so I felt to super chat. I super chatted Modern Day Debate. Now here's what is even weirder. I talked to James the next day or that night. My comments as MC Toon Live were not showing up at all, and I asked him why. He said because somebody put in the non-accepted word list MC Toon. He's got a bunch of moderators, some are flerfs. He's like, did one of them do that? I don't know. So he undid that, but I had to do it from my Conspiracy Tunes account, and I did a $5 super chat. And that so yeah, it was tough. But that super chat was misgendering is not loving, because they kept talking about the creator and love, Austin and this Nathan guy. Misgendering is not loving. And I said, stop being a fake, basically fake lover of the creator, fake being on the creator's side, because that's what that is. Anyway, so whether you agree or disagree with anybody's particular activities, an insult is an insult. It's not loving. So the hypocrisy is big. So Space Tomato says, just a little thing. They're growing tomatoes in space to test the psychological effects of having fresh fruits and veggies on the astronaut aboard the ISS. Hey, oh, that's pretty cool. And yeah, vegetables and plants and stuff are very different in zero G or microgravity because they rely on knowing on gravity to know which way is up. So anyway, what was I saying? I was showing this. I was in the middle of this. This was what they showed. What Brian Leak showed. That was the one. And then this is from Andrew. Anyway. Oh, Ruhif. I didn't even get to this. Ruhif is great. So Ruhif found this one, this measurement here in the Triangulation in Utah from 1927. And again, these observed angles, right? He actually did the work. I had to go find it. This is the actual page here. It was a little bit of work for him to actually do these. Good job, Ruhif. But he got these three angles. He ran summed them up and got 180 degrees plus 45.18 arc seconds. Again, spherical excess. No amount of words can turn an observed angle into outputting a radius. So it'd be interesting to see, to look at that, because the lengths of the sides there are in it, both in meters and feet. And so we could plug that in and see, does that also output the same radius? Did somehow the people who fudged this, according to Witsit, they would have to fudge this, right? All of it would have to be fudged with the radius in it. Well, the math that they have analyzed will definitely show that. So trending the board says there's talk of having time zones on the moon. Interesting. Oh, I see Michael J, who is Michael J. What do I call him? He's besmirching a dead person. Is here. About the besmircher of dead people is in there, and he got timed out. So let's see. Or Michael J. Yeah, the besmircher. I didn't know he was in here. Canon Carroll. You're talking to the wrong person here. Anyways, Canon Carroll is in here. Like this is interesting. I was talking with Danny Faulkner about this today. That so many flerfs think, they won't generally say it, but they generally agree with Lady Blunt. Lady Blunt was contemporary with Samuel Rowbottom, and she was in England in the years after he was there, and wrote a book even. She was a flerf. It was her position that you cannot be a Christian if you don't think the earth is flat. And so it seems to me that Canon Carroll agrees with that. Many flerfs won't outright say that like Lady Blunt did, but that does seem to be at least in their hearts. They think that it's a necessity, which is really weird. Really kind of sick, actually. But so, all right. Michael J. Smith, Colin Frank show. Colin show begins now. No, what I'm going to do is I'm going to work towards wrapping it up. I've been out. I'm way behind on like videos and stuff. I need to do the top left, and I want to get that this week. I have like 10 more that I want to do. The stuff that I measured when I was in the in Florida was super awesome, and I've shown one. I'll show another here maybe. Before I go, should I show one more of the things that I did? Let's see. I got I talked about it before. I got a macro lens to put on the end of the P1000. Come on, open up. Yeah, Gary, I don't need need to hear your crap anymore, Gary. So, all right, here you go. This is one of a few that I did. There you go. That looks, a flat earther would say, it looked flat to me, right? You should, because it looked flat. So, but what is that? Let's see here. This is a video. Let's see if what it looks like here. Yeah, this is after I got the extension on there. And so the focus, you can see the focus there. You can see what it is now. And the depth of field is like 1 millimeter. And the working distance is just like 5 centimeters. But anyway, there you go. It's a globe. But when it zoomed in, it looked flat. There it is. So, how's that? Well, one more. Let's see. Oh, this is good. This'll go to Quickie says you need a focus stack. I do. You're right. But all right. This is the globe that's on the shelf behind me that I got from Stan Trucker. And it actually has solar panels in it. And then it uses the magnetic field of the Earth to actually rotate. So there's probably an acrylic outer shell, and then there's liquid, and then on the inside is the actual globe. And it uses the magnetic field of the Earth to do this rotation. So I set it up on the table, and I took this with the P1000. So Stan Trucker, thank you for this. This is very cool. I will probably include this in a video somewhere, but you can see, I don't know if I want to have this particular one, but you can see my pergola in the reflection. So this is out my front window, so you can actually see the pergola, and it's cool that you can see that, but I don't know if you want to see that in like, I thought it'd be like a intro or an outro or something. So Canon Carol reported me for misinformation. Oh, Canon Carol, such a toxic person. Wow, Canon Carol, if that's the case. Yeah, well, Canon Carol, go back to hell from whence you came. Yeah. Flat earthers are just liars. That's it. They're all just liars. Right? The projection of suggesting that NASA is lying or somebody else is lying when you don't even have a map. You have no measurements. Everything that you do is lies. When people have to do like flat out truth Terry R. Eicher did, where he reposted that intentionally manipulated video from 2016 of the Blue Origin flight, where they intentionally flattened the horizon at height. That's a lie. Or the one that the biker scout did, where he intentionally flattened the horizon, claiming that he had automatically applied. This is disgusting. He had claimed that he automatically applied the correction for the fisheye lens when it wasn't even a fisheye lens. When you do apply the correction for that fisheye lens, it doesn't look anything like what he did. Nothing at all. So, oh, Michael J. Smith says that his real name is Michael Jonathan Smith. Okay, I'll take that. If that's your real name, I will happily believe you. So if you're not besmirching a dead person, then fine. Real Cygnus, any idea where we can get one of those nifty things? That is Mobus. I had something sitting here. No, I don't remember. I'm not remembering the name at the moment. So, Frank, no. No, not right now. No, it's not Morbius. I'm sorry, I'm drawing a blank, but I'm sure somebody could probably find it. Anyway, so yeah, here, flerfs, when you do an observation across water, the conditions where refraction is the strongest, and then say that there's no refraction, that's a lie. So flat earthers have to lie. If you want to actually seek truth, like you claim you do, then you would include refraction, or you would seek a place where there's less refraction, right? Do it over land on an overcast day at from high elevation to high elevation without skimming across the surface of the earth. That's ideal. Seek that out. You don't, though, because it disconfirms your pre-selected conclusion. There it is. Electroneutrinos is MOVA globes. So that's what it is. So, all right. There it is. So I'll be working on some videos to come out on Conspiracy Tunes, and then hopefully to get some top left nomination videos going. There's 2 done that other people have done, and so we got a few more. Planar Walks. Hey, go message Planar Walk. Tell them to get on it. So anyway, people, thank you very much. Thank you to the super chatters. Thank you to members. I've got a lot of members now. Thanks to Siggy Sigwall. I appreciate that. The scroll here is should be accurate. And the unless you're brand new. And the outro, which I'm gonna prep right now, the outro video is also updated. So thank you to them. Let's see, 2 weeks. 2 weeks from now, I got Brian Stavely, and he's going to talk about his favorite topic is a Mandela effect. So he's going to talk about that. He's a flerf, but we're not going to talk about that at all. So I get along with some of the flerfs. I've discovered that I get along fine with Jaron, Brian, Dion Smo, but it's Dion Poe. I think. I don't know. He says he's not. Anyway, that's what I got coming up for live debates. So I'll be looking for one for next week. So anyway, people, thanks a lot, and we will see you next time. Oh, wait. No, not that. This.